Yep.
Did you get a prompt for the meeting is being recorded?
Yes. I think, are we all in the room in the same place now?
Yes. Everybody's joined. Few people are joining in, but we are good to start.
All right. Yes, I guess I think I'll start. Well, so yes, good evening, everyone. On behalf of the Baldwin State School of Architecture, I would like to welcome Professor Neil Leach here today. Well, good morning, Professor Leach. I know it's early there at this time.
Morning. It is early, but I'm used to getting up to go surfing at this time, so I'm used to getting up now at this time.
So it's a pleasure to have you here with us to share your lecture, Do Robots Dream of Digital Sheep? A little bit about Professor Leach. I think we know Sir since for quite some time. We've heard of him. He's an architect, and he has pioneered many radical concepts of our times. He has taught and lectured at some of the finest schools of architecture in the world. He's currently professor at FIU, Tonji, and EGS. And he has previously taught at many other institutes, including the A, at GSD, Columbia, Cornell, SCI-Arc, IAC, and the DIA. He's a co-founder of Digital Futures, an academician at the Academy of Europe, and the recipient of 2 NASA research fellowships exploring 3D printed technologies for Moon and Mars. He has published 40 books on architectural theory and digital design, including L.B. Alberti on the art of building in 10 books in 1988, Rethinking Architecture, Digital Cities, Space Architecture, Swarm Intelligence, Computational Design, Architectural Intelligence, amongst many others. He's currently working on The Death of Architecture, the demise of the architectural profession in the age of AI, and interactive futures. Well, architecture, as it lies at the intersection of society and technology, has been shaped and evolved over millennia by humans and their tools. Now, since the past 3 decades, it has witnessed a radical shift, almost situated at the eye of the perfect storm. Technology has evolved from a mere tool-making exercise to a sentient, responsive presence. Can it or will it change the way we think, perceive, and create in the future? This lecture is based on material from the recently published Architecture in the Age of Artificial Intelligence, an Introduction to AI for Architects, and the forthcoming issue of AD, Machine Hallucinations, Architecture and Artificial Intelligence. Welcome, Professor Neil Leach. I think it's great to have you here, and over to you.
Thank you, Trey. That's thank you for that introduction, very generous introduction. We share a common link, I should say, at the AADRL. Just to say that I am British, even though I'm in California right now, and I refer to surfing. I'm on Venice Beach, and I have been for the last 2 years. But thank you so much for the introduction. Thank you also to Baldwin, who is who set this whole thing up and is an important part of the Digital Futures Initiative, which is an attempt that we've set up to try and share ideas around the world, with the idea of trying to democratize education and trying to bring ideas to everyone throughout the world. It's great to be here, and as it were, and it's also I have a special. I have to say, I have a special. We have a very special connection with India. I have personally, my father actually used to work in India. He claimed that he could speak Urdu. I don't think he can, and everybody claimed he could. but he used to make curries every week, and he was kind of known in the neighborhood as the person, Colonel Desmond Leach, and he would make these curries. So it was very much part of my background. Of course, in the UK ourselves, we have this very important interaction with India. We gave you cricket, you gave us chicken tikka masala, we gave you Land Rover, you gave us Shajah Bhushan, and so on. It goes on like this, and it's very much a hybrid culture. I think both cultures are a part of a hybrid culture, and of course, it is an Indian, Homi Bhabha, who is the primary theorist of hybridities. So we live in this kind of world where we're exchanging ideas. I just wish that you Indians would be more generous in letting us win at cricket a few times. But it's certainly it's great to be here, and thank you so much. What I want to do today is to talk about the material in these two books. And I don't know to what extent I'm preaching to the converted or not, but it seems to me that this is probably one of the most the introduction of AI into architecture is one of the most significant moments, I think, in the entire history of architecture. And I want to draw out and explain why I think that is the case. I also want to, as a theorist, I mean, I am going to talk a little bit about the technology as such and how certain things operate, but I also want to talk about kind of related domain, especially of neuroscience. And I want to mention a very close friend of mine, well, a close friend of mine, Anil Seth, whose father came from India many years ago. And he's now one of the world's leading neuroscientists as part of that cultural exchange we have. And I want to bring him in to try and talk about how, from a theoretical point of view, AI also opens up a whole series of interesting kind of debates. Having shifted from the time when I was at the AA, I was primarily known as a kind of a critical theorist, looking at the work of French philosophy, of people like Jacques Derrida, Gilles Deleuze, Michel Foucault, Helen Sixou, and so on and so on. I then embarked on trying to theorize the domain of computation, and it was actually quite challenging. At certain points, you can't say much about a robotic arm. It's kind of doing this, but what can you do to theorize that? Not much, apart from maybe develop a theory of the cyborg or so on. But with AI, all of a sudden, a whole series of kind of important issues present themselves. Not least the question of consciousness. The difference between human beings and AI is that AI doesn't have consciousness. That automatically brings us into a kind of philosophical, neuroscientific domain of theory. But beyond that, also, what I want to draw out today is what kind of insights we might look for in the domain of AI. How can AI become a mirror in which we can understand certain aspects of what it is to be human and what it is to be an architect, and what how the mind of the architect might possibly sort of work. So it's also an opportunity, I should say, to I guess animate, shall we say, the material in the book, because one of the problems about books, the first problem about books is that you can't necessarily have so many color illustrations. In my first book, we only have 8 pages, and of course, there is so much visual material. I'd love to include it, I couldn't. And secondly, you need to see animations of this. Most of these, I'll show you as many videos as I can of how this domain operates. So it's an opportunity to try and, I guess, add to the material that's out there. I would say just briefly also the 2 books I'm going to talk about. The first one, which came out in December the 16th in the UK anyway, Architecture in the Age of Artificial Intelligence, it has mainly text and almost no illustrations, whereas the second book, which is coming out in May, which is an issue of Architectural Design, guest edited also with Matthias Del Campo, has lots of illustrations and not much text. I mean, ADs now have about 2,000 words of text, not very much. So they're kind of complementary. And I want to add something to it in terms of animations today. But I'm going to go back to actually a title that I used when I first started talking about AI back in 2019, I think it was. Do robots dream of digital sheep? And some of you might recognize the image in the background. The title, of course, is based on the title of the book by Philip K. Dick, Do Androids Dream of Electric Sheep? And as it says here, the inspiration for Blade Runner, it is the novel on which Blade Runner was based. And I don't know in this audience how many have seen the original Blade Runner. I'm sure that many have seen the sequel, Blade Runner 2049. But if those who haven't, I really want to recommend Blade Runner itself. It's a cult movie. It's a cult movie for architects, and I think it's superior to the second version. So I'm currently in LA, sort of on the beach, almost on the beach, and I wanted to start by referring to a meme that became popular on the first day of 2019. So above you can see LA as it exists by night. Then all of a sudden there's a different view on January the 1st, 2019. And those of you who've seen the movie Blade Runner will recognize the Tyrell Corporation. This is an image from the movie. And the point is that 2019 was the year in which Blade Runner was set. So all of a sudden, LA became the city of Blade Runner in 2019, the anniversary, or the year in which it was set. So just, for those of you who don't know the movie, let me just give a very brief overview. The director was Ridley Scott, who's from the UK. Who himself, he had a background, he was trained in art, and I think the visual effects in Blade Runner are very spectacular, largely because of Ridley Scott's background as an artist. It was released in 1982. It was initially a flop. It wasn't that successful, but then since then it's become, for whatever reason, it's become very popular with architects, and it's become a cult movie as a whole. Why it should be popular with architects, I'm not quite sure, because there's not so much architecture in it, apart from the fact that there are a couple of scenes that are interesting, and since there's the Ennis House by Frank Lloyd Wright that's in it, and also the Bradbury Building, which is a kind of important icon in LA. But it's become a cult movie, and I think it's one of the most significant and important and insightful movies ever released, personally. So let me just tell you the story for those of you who don't know. It's about replicants. Replicants are bioengineered life forms. They're not necessarily AI, but they are artificial life forms. And the purpose of these replicants, who are manufactured by the Tyrell Corporation, is that they're designed to serve, especially in the off-world colonies, as it's put, colonies in which the conditions are particularly harsh, and these robots are designed to withstand that, and because of that, they are potentially dangerous. So they're given as kind of safety measure a 4-year lifespan, so that they don't become too dangerous. And in the story, there are 6 of these replicants who kind of form a mutiny, and they come back to Earth with the express intention of trying to extend their life. They're coming to the end of their 4 years, and they want to extend their life. So that's essentially the story about it. The challenge is, and here we're seeing on the right-hand side, the main character in terms of the replicants, that is Roy Batty, who's played by Rutger Hauer, who was a Dutch actor, born the same year as Rem Koolhaas, who's also Dutch as well, and with him is Prissy, one of the 5 other replicants, and the real challenge in many ways about these replicants is that they look absolutely identical to human beings, and it's almost impossible to tell them, and they're lethal. And so Harrison Ford plays Deckard in the movie, and Deckard is a kind of cross between a policeman and a bounty hunter, and he's charged with the responsibility of retiring, which means killing these replicants because they're so dangerous to society. And the challenge then, of course, is precisely knowing how to detect when how to detect them, because they look so similar. Now, that on the one hand makes them very easy to cast in terms of the movies. In terms of the movie, human beings can play replicants. At the same time, in terms of the story, it becomes a challenge to how to recognize them. And there is this elaborate test which is that is used, the Volkamp test, it's called, where they look at the eyelids and the reaction in terms of the eyelids, and also ask questions trying to detect empathy. And of course, replicants don't have much empathy. So that's the only way they can tell. And this particular scene, of course, is where one of the replicants actually attempts to shoots and doesn't actually kill the person interviewing, but he goes into an iron lung to try and in recovery. And the iron lung or the ventilator is something interesting in some way, because there is another layer to this which has never been pointed out by other people, I don't think, and that is to say that the Blade Runner itself was set on the 19th to 21st of November 2019. We know that from the the second movie, the clues are there. And then if we look back on it, the 17th of November, so 2 days before this was supposed to happen, that's when COVID was first detected. And of course, COVID is also lethal and also difficult to detect. So there's a kind of a layer of kind of testing that's going on. And alongside the question about AI, then you can also think about the Turing Test, which was developed to try and see whether or not AI could convincingly kind of replicate human beings. So there's a real series of strange parallels emerging in terms of the story itself. And in many ways, the story was also kind of prescient in other ways. Here we see Roy Batty playing chess against Eldon Tyrell. And back in 1982, when this was released, this was before the very famous moment in 1997 when Garry Kasparov was beaten by Deep Blue. The first time that a world chess champion had been beaten by computation. I know that in India, chess is very important as a game. So it was kind of prescient in that respect. I should say this is Roy Batty was an example of the Nexus 7, the most sophisticated of all the replicants. It was also this is because he comes back, and eventually, when he finds out that Eldon Tyrell, seen on the right hand side, when he finds out he's unable to extend his life, Roy Batty just kills him. Kind of, you see how brutal and merciless these replicants can be. But there was something that struck me yesterday when I was I gave a talk elsewhere, and that's to say that the name Eldon Tyrell is kind of interesting. I mean, if only they left out Eldon. If you left out the D, you'd have Elon Tyrell, and that would have given another sort of layer to this whole sort of story, which makes it, to my mind, astonishingly interesting in terms of precedent, because there were a few things that the movie got wrong, and here is one example. It's Rachel, who subsequently has an affair with Harrison Ford, with Deckard, and they have a baby, as we find out, which is itself very significant that a replicant can have a baby, who then becomes somebody who designs dreams. And the theme of dream, of course, is very central to the theme of Blade Runner. All these replicants are given dreams of someone else. And there's also the dream plays an important role in terms of the movie, those who've seen it, in terms of unicorns and other stories and so on and so on and so on. But the one thing they get wrong in terms of the story is that smoking, which might have been around, clearly was around in 1982, I can't even remember this now, that died out. That was wrong. But what was correct, I mean, there are many things about the movie that was really correct. I mean, I think, so we don't have replicants, but we certainly have AI infiltrating our society. And I guess the point about AI is essentially it's invisible. It's basically, when you think about AI, don't think about humanoid robots, think about algorithms. It's just simply software, essentially. And you can't see it as such. Therefore, it's all around us, literally everywhere. On our phones, it's kind of, it's finishing off our sentences on Gmail. It's filtering out our spam. It's introducing us to partners. It's recommending us movies and books and so on and so on and so on. It's controlling when we're driving. It's telling us we're shifting out of lane or something. It's in the house. It's controlling our heating. It's our robotic cleaners and so on and so on. It's everywhere today, in the office, in the car, in the house, and so on, and yet we can't actually necessarily see it. It's all around. In a sense, from that point of view, it's kind of similar to the replicants. We don't have flying cars, but we do have maglev trains, we do have drones and so on. And we don't have the Tyrell Corporation, but what we do have is basically life is dominated by high-tech corporations or tech corporations, just as Tyrell Corporation was. In other words, we have kind of Google, we have Microsoft, we have Amazon, we have Elon Musk, Eldon Musk, maybe he should be called. We have SpaceX, we have Tesla cars, and so on and so on and so on. That aspect was remarkably correct. And in terms of these these facades of buildings coming alive with advertising and animations and so on, if anyone's been to Shanghai, you could maybe even say that this vision is almost a little bit old-fashioned. So to my mind, Blade Runner was incredibly prescient in what it was predicting about the future. In fact, Elon Musk was himself very much aware of this. He launched the Cybertruck, seen on the bottom here, based kind of similar, shall we say, to the designs that appeared in Blade Runner and also in the second Blade Runner movie. And he released it on the anniversary of Blade Runner. So, or not the anniversary, the day on which it was set. Let's say the 19th of November, 19th to 21st of November, 2019. But I want to talk first of all about this individual, Refik Anadol. He's from Turkey, and he's now based in LA. He's a media artist. He's not an architect, but he does use architecture as both his canvas, as it were. He projects onto buildings, but also as his material. He uses data based on architecture in a lot of his work. And when Refik was when he was young, his mother gave him a video cassette, and these are the days of video cassettes, right? I guess he was 8 or 9 years old, I'm not quite sure. And back in Turkey, and she gave him this video cassette of Blade Runner, and this had a profound impact on him. This incredible vision of the future, and in many ways, it's the story behind his own works. That's partly why I want to introduce this through Blade Runner itself. And in 2012, Refik came to LA to come and study in the media art department at UCLA to study media art. And the first thing he did was get into a taxi. He arrived at 2 o'clock in the morning, and he got in a taxi and he went to see this building, Frank Gehry's Walt Disney Concert Hall, which was, Gehry was his hero, and he came to go and see this, to pay homage to this building. But when he arrived, he discovered this. He discovered that the lights were off. He wasn't expecting this. He thought that he was moving to the city of Blade Runner, that it would be alive the whole time, and instead he saw this silent building. And at that point, he developed this project to try and bring Gehry's building back to life, to give it life again. And he was also, in context of Blade Runner, he was interested in how, since Rachel in Blade Runner was given someone else's memories, he started asking the question: can we give a building a memory, and can we give it consciousness? Can we make it come alive in some kind of way? And this ambition eventually was realized in 2018, which really kind of gives you a sense of the timeline we're talking about. This doesn't go back very far. What I've been talking about today goes back to the very earliest, 2014. And in 2018, he was commissioned to do this, which is to say, to create an installation of 42 floodlights, which were trained on this building, and with the help of Google. Google AMI, Google Artists and Machine Intelligence Group, and also, and I'm just blanking on his name now, but there was an Indian AI computational musician who was also involved in this in this project, and to bring it alive. And so what this commission then was, it was to mark the 100th anniversary of the LA Philharmonic, and the challenge was to basically to use to draw upon all the kind of the data, all the history, all the of the LA Philharmonic, and to use that data to feed into an AI-based animation that would bring the building alive. So let me show you a video of this. I can't show the sound for very long because I'm going to contravene the copyright laws if I do. But let me just show you. Maybe I'll give you 5 seconds towards the end. So this is really essentially what he did, and the project is divided up into 3 sequences. The first one is memory, then there's consciousness, and then there's dreaming, as he put it. And these are obviously kind of, in a sense, these are terms that refer to humans, not necessarily to AI, but nonetheless, he's attempting to try and see whether by projecting these images onto the facade of this building, he can somehow give the building some kind of consciousness, some kind of memories, as indeed happened in kind of Blade Runner. So what we're seeing at this stage is the final section, the dreaming section, where all the data, there was a huge, astonishing amount of data that was used to this. All the data is kind of fed into the computer, and we get what is called a hallucination of these images onto the building itself. And it was dramatic. I was actually there with some of my students for the moment in October 2018. It was when this happened. And even though there has been plenty of examples, well, not plenty, but several examples of AI generated media art before then, this is really when it became really public, in a public space, a large scale operation. And in many ways, I would say this is when AI met architecture, in a sense, because it was projected onto such an iconic building. And the other kind of comment to say that it was supported by Google AMI, had just been formed as a kind of artist machine intelligence group, as a sort of resource to help artists who were interested in working computationally. So let me just, maybe I can give you just a kind of 5-second section of music without contravening the copyright. I'm not quite sure, but anyway, here we go. Anyway, and what was interesting about this was a comment that was being made by one of the leading figures within the LA Philharmonic, where he said, "At last, I got a sense of science fiction itself in LA." So in some senses, in this moment, LA was being returned to being the city of Blade Runner. It was an astonishing event, and it had a huge impact on people, and made us all in architecture certainly aware of the potential of what LA might be able to do, what AI might be able to do. But that was not architecture. It's projected onto architecture. So the question was, how could we project this on? How could we involve architecture itself? And so 2019, early in 2019, I joined up with Google AMI and also Zaha Hadid Architects, and in particular Sharjeh Bouchat and Patrick Schumacher. And we were going to, we wanted to, we proposed to curate the British Pavilion for the Venice Biennale in 2020, which of course was delayed in 2021. What we had imagined was that we would be able to use AI to hallucinate buildings. That was the idea. Surely we could be able to do this. Actually, we didn't get anywhere. This is kind of interesting. We weren't even shortlisted. I mean, it wasn't even a shortlist. There were 9 entries that were shortlisted, and we weren't even on that. It was a dream team, Google and Zaha Hadid Architects, and we weren't included. In some senses, I don't know whether that reflects a certain antagonism towards computation or what, but it was astonishing because by now AI has really come of age. Anyway, this was a data set, a hallucination based on a data set of Zaha Hadid architect images that was done by Refik before even the Venice Biennale would have happened, where he realized exactly what we were talking about and made it happen. It's a version of GANs, style GANs. I will explain what that is in a moment. But what is astonishing is at a certain moment, as you go through this kind of this latent spacewalk, you get an image of something that is quintessentially Zaha, and there it is, and that's in fact the image that we used on the front cover. It's by Refik Anadol for this particular book, and maybe I should just say a brief thing about the book itself. It has a certain history. I was initially approached by Helen Castle, who, as many of you know, was the editor, a remarkably good editor of AD, architectural design. And she's really the one who kind of, I think, established it, launched it, or didn't launch it, but established it as such an important journal with a very inspired kind of editorial policy. And she had moved to the RIBA. I don't know why, because I think AD is more important, but anyway. And she wanted me to look at what the impact of AI would be on the profession, and I thought about it for a long time. I came back and I said, okay, I've got a title. I know what I would say, and the title was "The Death of the Architect," which, and she said, "Can we have a question mark?" Because she was working for the RIBA, right, the Royal Institute of British Architects, and I'm not sure our members would like that too much. She said, "Can we have a question mark?" And I said, "Well, I think maybe we need an exclamation mark, because I think what is very obvious, and maybe that's extreme to say the death of every architect, is that these tools are going to have an impact on the profession. There's no question about it." Anyway, I did have a contract with them, but I felt that somehow they wanted me to soften things, so I ended up shifting to work with Bloomsbury. Bloomsbury, you might know, are the publishers of Harry Potter, anyway, and they're also based on Bedford Square. They're the same square as the AA in London. And I was working on that. They offered me a contract, but I was working on it, and I found myself very compromised because, on the one hand, I was talking about how amazing this AI could be. At the same time, I was kind of aware of the fact of, Elon Musk and many other people, Stephen Hawking, have spoken about the dark side of AI. And anyway, at a certain point, I thought, well, this is a bit kind of difficult. How can I write about things in both? And Elon Musk is the same, right? He's using AI the whole time, but telling us that it could be dangerous. So in the end, I decided I managed to convince Bloomsbury to do two separate books. One with a white cover, say the angel, as it were, the good side of AI, and one with a black cover, which is going to be the devil, the dark side of AI. Because basically there hadn't been a book published. In order to go and talk about that, I had to go and lay out what AI was in some senses. So this is the first of those two, which is talking about what AI is. It's introducing AI to everyone. It's talking about what it does. It's giving a history of it. It's talking about its background in terms of the world of art, of media art, before we get into architecture even. It's trying to sort of to contextualize things. And the next book is going to be the one with the black cover, looking at the dark side of AI. Now, I want to stress, I don't think that there's anything inherently negative about AI itself. There are a lot of books that have come out that have been skeptical. Shoshana Zuboff's book, Surveillance Capitalism, which links it with capitalism. There's also books, AI Atlas, which are kind of skeptical. I'm not negative about AI. If you look at the dark side of AI, it's a question of how you use it. You can have a kitchen knife, and you can murder someone with a kitchen knife. It's not the kitchen knife's fault, right? So to my mind, AI has nothing negative about it, but I do think that it is terrifying, by which I mean the potential is absolutely terrifying. It's amazing. I was first alerted to this when I boarded a plane once in LAX, Los Angeles International Airport, and I had my boarding pass, and they were testing out facial recognition, right? So we don't need that, just look at this panel. I looked at the panel and it recognized me. Now, it recognized me from every single other person on the planet. Every single other person on the planet. And that was terrifying. So my view is basically that AI is incredible, terrifyingly incredible, terrifyingly capable. The other book then that is coming out is the AD, Architectural Design issue, which is guest edited with Matthias Del Campo. And the nice thing about this is the first book is primarily text and very few images. This is primarily images and very little text. So they form a kind of complement to one another. This will be coming out in May, and I will talk about the image on the front cover, designed by Cor Pimmelplau, in a moment. So it's nice to be able to kind of illustrate the incredible, because it is the result. What AI can generate is mind-blowing in terms of its visual impact. But then today also I can show you the animations of this thing. So I want to start off with the question of can machines dream? To go back to the title, and if so, how? And the traditional approach, and there are many comments on this, going back to Ada Lovelace herself, the first, we could say maybe the first computer programmer, or the first person who envisioned the possibility of computer programming. Many people have said, and Alan have said that basically machines are not creative as such. They do what they're programmed to do, but humans are the ones who really can be creative. Machines are good at certain things, but people are the only ones who can create an image that does not yet exist. Machines do not have dreams. These are the words of Makoto Sei Watanabe, that from an article we published in 2017 in a book called Computational Design. I would say that he actually does go on, to the full quote, he does go on to say, well, maybe at some point they will be able to dream. But at this point, he was saying they do not have dreams. And that's essentially something that I think needs to be challenged, whether we can use the word dream or not. Certainly the fact that they are able to produce something that does not yet exist. So just to kind of explain and very briefly what we're talking about here. On the left-hand side, you can see the neural networks of the brain, the synapses and the neurons of the brain. On the right-hand side, deep learning, and the neural networks of deep learning. And one of the things that really made AI take off was the development of deep learning itself, or machine learning, and then deep learning through connectionism. Now, I don't go into this, but there are different camps, different ways of approaching AI. And for a long while, even though the idea of modeling the AI on the brain, which is essentially what connectionism is, was started off as being kind of dominant, because of certain politics inside the whole domain, symbolism took over. But in about the early 2006, 2007, connectionism, some people began to realize how incredible that this deep learning could be, and there was a kind of revolution. And neural networks belong to this way of thinking. It belongs to how they operate, and especially the domain of deep learning itself. And what we basically get, this is a neuron. It is so loosely modeled on the brain itself that some commentators, I'm thinking here of Melanie Mitchell, who's written a really wonderful book on AI, Introduction to AI for Thinking Humans. She doesn't like to use the term neuron. She uses the term unit instead. But anyway, these are neurons, and should we just say it's inspired by the brain, not actually modeled on the brain. And then these are the synapses that connect the neurons, and the synapses are governed by weights which control the flow of information. And basically, we go from left to right, feed forward and get the result at the end. And I would say also these hidden layers. There's up to 1,000 hidden layers in these things, and that's where the term deep learning comes from. So they are loosely modeled on the brain, but only very loosely. And the way that it kind of operates, basically, what they developed in the early 2000s was how you could use it for image recognition, which is it seems to us fairly straightforward. I mean, we all have facial recognition on our cameras now, but it wasn't when it first arrived. And essentially, what you get is that through this, the kind of pixels of the image are kind of processed through until eventually you'll be able to recognize that this is a bird. This is a bird. And the challenge, though, the real holy grail of AI was how you could do the opposite. Instead of going from left to right, how you would go from right to left, how you could start off with a concept of a bird and hallucinate an image of a bird. That was the challenge. And one of the early attempts was to do this was what we called became known as deep dream. And there was a guy called, maybe I'll just go back a second, Alex Morgenstern, who was working as an engineer with Google, who realized that you could, in a sense, perform a kind of neuroscience on AI, and he realized that actually this the convolutional neural net could actually work the opposite way. Instead of going from left to right, instead of going from an image to a concept, you could go from a concept and hallucinate this image, which is interesting because what it suggests is that there's the operation of let's say recognition or interpretation is the opposite of generation, of creation. And that in architectural terms would say that there is a difference between designing and working as a commentator, a theorist, or a historian, or so on. And it tends to suggest that might explain, for example, why not so many architects are, not so many theorists are designers, and not so many designers are theorists, because it would seem to suggest that it's an opposite modality. These two are kind of opposing one another. Now, what came out was these very trippy images, which will eventually you can now download an app, a Deep Dream app, and you make your own images. Where what basically happens if you train a data set on clearly these are dogs and I don't know, serpents or something, or snakes and things, and this looks like an oil lamp. Whatever you train it on, it is basically going to hallucinate based on the data that you put into it. But the real problem is that it's invariant to pose. In other words, it's all over the place because in the previous operation, you compress things, you lose certain information, and therefore you have no information on which to base the whole thing about where things should be. So you get this tripping image, and this had a huge impact on the art world very briefly. But the real breakthrough, which actually happened a year before, but didn't really filter its way into the world of art until later, was the generative adversarial network that was invented in 2014. And the way that this works is that you effectively have two neural networks. One operates as what's called a generator, and one is called a discriminator. The generator produces images, and it's based on random noise. So it kind of produces these images, which then the discriminator judges in terms of a training set and compares it to the training set. And if it's convinced about it, it accepts it. But if it's not convinced, it rejects it. And as a result of this, the generator is effectively trained to improve the images until it reaches the standard of the discriminator. We can see within this the kind of Turing test going on in some ways. That the Turing test is about whether you judge whether AI is convincing as a human or not. And we could also maybe read this as a kind of way, maybe in the art world, someone who's producing, let's say, a fake Van Gogh, whether or not an art critic would accept it, and so on. So there's a kind of clear analogy going on between these things. But essentially, what happens is that they train one another, and the discriminator trains the generator, and the generator trains the discriminator, until at some point you just remove the discriminator, and the generator should be producing in new images. Now, just to say, going back that the theory of kind of the theorist versus the kind of creator, in some ways you could see that again being played out in the way that we as architects operate, in the sense that those who are creative has to have some criticality in there to improve their creativity, And those who are, let's say, theoretical need to have some creativity in the way they approach things in order to make their theory more acceptable. So those two dynamics are obviously happening in terms of the world of the world of architectural education. And what happened, of course, was this. This is one of the early versions, actually, of GANs. I think it's a progressive GANs. Since then, we went on to style GANs. There's now style GANs 3 come out, and it's very clear that Watanabe is wrong. That the computers can hallucinate or dream images that do not yet exist. These are images of people who do not exist. This is, and in many ways, kind of shocking in some senses, but this is what happens. Basically, you take a data set of Hollywood models and stars and so on, and then you can hallucinate images, all of them pretty damn convincing. And as it goes on, as it gets further and further, and this is the logic of deep learning, it gets even better as you go through. The reason why faces were chosen initially is that they're kind of vaguely symmetrical, one eye on either side, and therefore they're relatively easy. And there's also a lot of data of photographs on the internet and so on. And eventually, of course, this can feed into architecture. This is the work of Wan Yu He. Wan Yu He, actually, she's actually one of my doctoral students on the DDES program at FIU. And she is, I think, probably the world leader in terms of developing AI software for architecture. She has a company called XCool that's based in Shenzhen in China. It's called XCool because she used to work for Rem Koolhaas. XCool means X-Koolhaas. It also means in the Urban Dictionary, it's hypercool. It's the ultimate of cool. Now, the previous video I just showed just now, there is a website you can go to called "This Person Does Not Exist." Every time you refresh your browser, you are going to get an image of someone that is incredibly convincing. And there's also a website that the XCool put up briefly called "This Building Does Not Exist," which basically was showing you hallucinations of buildings, because this is not there is no building here. I mean, this is hallucinated by AI. It is based on a data set clearly of modernist buildings, and it is hallucinating all sorts of potential new buildings. It is only two-dimensional, and in a sense you can't control it, therefore the limitations of what you can do, but nonetheless this was a huge step forward in a sense of using AI to hallucinate buildings. Now, Wan Yu's working primarily for developers, and much of the stuff that she does is, you could say, is a bit kind of straightforward, maybe. And these are some examples of what you can produce. And if you look very closely, you can see there's slight glitches, imperfections, but with time, these are eventually going to disappear. And there is something already we can see that is pretty impressive about what AI can do in terms of hallucinating potential buildings, albeit two-dimensional image of buildings, and albeit in the sense of a certain lack of control. But there are other possibilities there. And here I want to show you something that I think is I mean, this is as a kind of glimpse of the future. This is a study that was done, or an entry for competition by XCool, where they were using AI to generate the most environmentally, looking at comfort and so on, and wind comfort and so on, the most environmentally appropriate form. And what is interesting is they start off, as you might have noticed, with a kind of rectilinear form. And it breaks down because that's not the most efficient. It breaks down, and eventually you end up with some, let's say, Gary-like form. So here you are, you can see the rectilinear thing breaking down. It's not, so we get something emerging that is truly astonishing. They entered this competition. They were competing against 200 different architects, and they won. And this is a sign of the future. So forget those kind of developer kind of concept. This is really, I think, going to be hugely important. And of course, there are other constraints that one can input it. And you can see that there is something else astonishing that is happening. So let me also introduce you to someone else from southern Florida. Actually, Daniel Baldwin, he's originally from Romania, but he teaches at Florida Atlantic University, very close to FIU, where I've been teaching. And Daniel Bolojan is really, he's incredibly modest, but he is the genius behind some of the new things emerging, especially the work of Corp Himmelblau. And this is the Deep Himmelblau project, which is on the front cover of the book, which is an ongoing project where they're using various forms of GANs and other techniques they won't disclose because they're kind of top secret, to hallucinate potential other buildings based on the data set of existing Corp Himmelblau designs. And Wolf Prix is really sold on this. And if you think about Wolf Prix, he's kind of like, he was someone who came of age, who really hit the scene in the age of decon and deconstruction, and now he's leading the field, or Corp Himmelblau's leading the field in terms of AI. And I think he gave a lecture once on digital futures from with Tom Main, actually, together they were giving a discussion, and it was entitled From Decon to AI. And I think this is the point. This is the point, because what you get is that, to my mind anyway, it is the next biggest breakthrough since that moment back in the late 80s, early 90s, when all these incredible guys, including Zaha and Gary and so on, hit the scene and produced this new form of architecture. This is now what I think both Matthias and I think is the first genuinely 21st century design technique that is infiltrating architecture, and it can be seen to be the next step on from deconstruction, the next radical approach towards things. And of course, this is ongoing research. Every month it's improving and so on. And that's one of the challenges about publishing in AI, right? The book is out of date already because many things else are happening. But this is a glimpse of what you can get. And actually, frankly, it's not bad. It produces things that look kind of, shall we say, coherent. Anyway, so also there was a video that was done, which this one I quite like, because it's using cycle GANs, which is say it's two unpaired data sets. So unlike style GANs, where you're basically interpolating because you've got a limited data set and you're simply finding something within that data set, with cycle GANs you're crossbreeding one data set against another, and therefore you're extrapolating. At least that's the way that Daniel Bolojan sees it. Extrapolating, come up with things that you would otherwise not have had. And this is based on clouds plus Corp Himmelblau architecture. If you think of the name Corp Himmelblau, that's a kind of wordplay of co-op of Himmelblau and Himmelbau, because the L is in brackets, and Himmelblau means sky blue thinking, and Himmelbau means kind of building in the sky. So clouds become an important part of that. Anyway, this is ongoing research that they're doing, and I think this is the kind of state of the art right now in terms of the most progressive architectural practice. And Daniel Bolojan is a real genius. So what I would say is there are a lot of people in AI, and I will not mention any names, but particularly who claim to be experts on AI, but really don't know that much about it. Daniel knows absolutely, he is the world leader, but he's so modest you wouldn't know. So I would sort of be careful who you listen to, because there are some people who don't know so much. But Daniel Bolojan, you should try and get him to give a lecture for you guys, because he's a really fascinating individual, and he's really much in charge of things. And this is his own research that he does also, based on Antonio Gaudi's Sagrada Familia Church in Barcelona, where he's been conducting an experiment whereby he uses cycle GANs, again, two unpaired data sets, to take the data of the Sagrada Familia, images of the Sagrada Familia, and to pair them up with an image of a video of walk through a forest. So you've got trees and you've got the Sagrada Familia, and out of that you get this kind of extrapolation of something completely weird and completely new and different. Here you can see This is the walk for the forest. You can see how that is being bred off with the other one to create this kind of hybrid kind of condition. And again, this is just work in process. As we go through, we're going to see huge developments. I like to kind of use the expression that Ben Bratton comes up with, saying that we are in the silent movies period of computation. Things have hardly begun. And I think in terms of AI, we're even further back in the sense we haven't hardly begun. But we can anticipate. We can anticipate certain developments that are going to be radical and they're going to change things. I was just watching some of the work of X-Cool on digital futures the other day, and that struck me. You know, when I was looking back in the 1980s, when I first became aware of this as a student of computation, it was very unsophisticated. I mean, really, really unsophisticated. But now, you know, straight computational design is pretty sophisticated. And if you think of AI and how that will probably develop, you're going to see enormous advances over the next few years. We're just at the very beginning of something, and just as silent movies led to something astonishing, we are in the silent movies period, most definitely, of AI at the moment. So, and it isn't just that. I mean, this is obviously, you've got to be a super user, as Randy Deutsch would say, to be working in this area. But also, I think there are people now who are using more accessible techniques. And this is a work, I should say, India comes into this twice in this particular project. One is the fact that one of the tutors that supervise this as part of a workshop at Digital Futures is a guy called Maya Mistry, who is a graduate of Illinois, the school in Illinois, and he's now teaching this technique, which is basically VQGAN and CLIP. And secondly, this is actually the theme of this is, or the prompt is futuristic Indian temple. Now, VQGAN and CLIP, I'm not going into the details of this, but VQGAN, CLIP comes out of GPT-3, which is this incredibly powerful program developed by OpenAI that is a natural language processing thing and has produced some incredible results, absolutely incredible results. It can generate text that would convince you it's written by a human. And there are lots of stories there I could go into, but I won't go into it. But CLIP was a version that was developed to hallucinate images, and you put it alongside VQGAN, and together you can get this astonishing program, this kind of latent spacewalk. The others, I should also mention, there was actually a pre-prompt in this before the prompt. So the prompt was a futuristic Indian temple. The pre-prompt was the work of three architects, Jan Sumar, Wolf Brix, and Tom Main. And out of this comes this astonishing work. This is the work of Giovanna Pilaka, who, along with Baldwin, is part of our Digital Futures initiative. She's an architect from Peru who's just started teaching in the School of Architecture. And this, as I say, was part of a Digital Futures workshop that was done last year. And this is, it's actually pretty amazing. And I think this kind of points towards one of the real potentials of AI, and that is that AI can be a kind of muse. People talk about less AI versus humans and more kind of AI as an extension of the human intelligence. So it becomes a prosthesis that opens up these possibilities. And one of the other kind of comments that's been made about AI is how it can become a kind of muse to the architect. Hans Meyer talks about this in terms of it is kind of inspires you, opens up the possibilities of what things might do. So anyone can do this now, and my students are using GANs the whole time. And they're fascinated by it. And I would say also with this particular technique, VQGAN and CLIP, I came across one student who produced some really amazing work in the same workshop, and he said he was terrified. He said he was terrified by what this technique could do. So it is clearly being used in, let's say, a certain kind of creative way. And it also, I think it's opening up the possibility of what we could say is new forms of creativity. In other words, if you use AI and embed it in other kind of processes, you can also develop new techniques. This is a project that's been done in SciArc, by Casey Ream and Laura Michelin, working together alongside the guys from Lifeforms, that is to say, Damian Jovanovic and Lydia Klakovic, and it's called the new Campo Macho, where you use AI first of all to reinterpret Piranesi's Campo Macho plan and to generate a kind of architectural landscape. At the same time, you have these AI driven forms that are navigating, populating this landscape. And I think this is another domain in which we could operate. Also, this is life. I'm going to just play a bit of. I'll keep quiet for a second. Just play some this sound because this is copyright free.
The fingertips, the light, the sound, the colors of the cloth are all currents in the brain. When we feel a thing, we are not compelled to think of it, but merely perceive it. The feeling we feel of the thing is an instinctive feature of our personality. A few pleasant surprises await us in life. The world that follows us is more interesting than the fact of our duration. The feeling of distance.
Okay, so one thing I would also say about this technique is that, I mean, I'm not such a great fan of the metaverse. I don't know how useful it's going to be, but I do think there's a real potential of using the domain of computation as a kind of digital twin. In other words, a way of sort of modeling the world itself through real-time interaction and using the space of computation to explore possibilities. I would say that one of the most significant aspects of the application of AI has been in the use of in its use to control traffic and to alleviate traffic problems. There's a company in China called City Brain that develops an AI as a digital twin that models and therefore controls the traffic in certain cities, and according to them anyway, has had a huge impact in improving traffic flow, in improving getting emergency services, and also be able to spot accidents before they're actually reported, and so on and so on and so on. But to my mind, what is really interesting in this thing is to be able to possibly to simulate potential operations computationally, which is easier to do than actually making a mock-up and actually trying with human beings themselves, and therefore to develop a tool that might generate a kind of space that will respond to occupation, to the behaviors of agents that are occupying their space. And that's something that actually is part of Daniel Bolojan's doctoral research, is also part of Manu Her's doctoral research right now, trying to use this domain as a tool, as a kind of alternative universe, as it were, and a tool to be able to model and generate spaces that might match the behaviors of the agents. Anyway, but interesting as all that is, and it is astonishing in many ways, the real kind of driver of change is not going to be that. The real driver of change is going to be the domain of practice and this kind of thing, right? It might strike you as being not so revolutionary in terms of its form, but I think this is going to be revolutionary in terms of office practice. And I'm referring here to the work of Spacemaker AI, well, this is just because this is an example of it. Spacemaker AI and Xcool are, at least were, the two leading companies, I think, in the world in terms of developing AI software for architecture. Spacemaker, we had a Digital Futures. We used this platform to have a discussion back in 2020 between Howard Hochland and Wan Yu He. And it was very interesting seeing them together. I would say that Xcool is much more progressive in terms of deep learning, but nonetheless, they both. It was interesting. The one company was based in Shenzhen in China, and the other one, a Spacemaker, was based in Oslo in Norway. They'd come to the same conclusions about how they could use this thing. Now, the point is this: they used the AI, in fact, actually quite straightforward, good old-fashioned AI to model this and to test it out in the sense of trying to find the designs that would perform best in terms of wind comfort and views and so on and so on and so on. They were bought up by Autodesk for 240 million last year, and it's clear that Autodesk can see this is where it's going to happen. And even though the forms look straightforward, I think it's what important is to notice that it's coming up with things in a very interesting kind of way. I always show this slide after I've been talking about AlphaGo, which I'm not going to talk about today, except to say there was the most astonishing match that took place between a program developed by DeepMind in London and Lee Sedol, one of the leading Go players in the world, that took place in 2016. And no one expected the AI to win because Go is incredibly complex. There are more potential moves in Go than there are atoms in the universe. No one expected Go to win. But the point about the particular match is that AI could come up with moves that no human being would ever have thought about. And there was one incredibly important move 37 in game 2, that everybody thought was a mistake. They thought it was a mistake, and they just think this is the computer glitch. It's whatever. Not at all. Not at all. This was something that, and this is really points towards the potential of AI. It operates beyond the level of human intelligence. Beyond the level. We can't even recognize it. 100 moves later in this particular match, AlphaGo won because of this one particular really strange, unorthodox move that happened. And most human players play by intuition. They don't really think more than 1 or 2 moves ahead, if that, And here we have a system that was operating potentially 100 moves ahead. And this is the point, is that we can't even comprehend. We cannot comprehend the level at which AI is working. It comes up with solutions here that no architect would have thought about. There were plenty of architects in the room who were very experienced, and yet it would come up with something absolutely radically new. And I think this is in some senses, the point about the limitations of the human mind. We only have a certain capacity. And when we're dealing with urban context, with the kind of complexity of urban situations, often there are other possibilities that we haven't thought about. I always go back to an example at the AA in one of the studios. I think it was Siranaki was teaching it, and one of the students came along and he said, I looked at the possibilities here and there's 6. And you think, why 6? It's always 6, 10 or 4 or something like that. It's always a certain number. And the next student came in and said, I've just run this through the computer, and there are 485 permutations, of which only 385 are really boring because they're all the same, but here they are. And that's the point. It can search through options that we could never even imagine. And I think it's important, therefore, to distinguish between what I would call urban planning, which is, say, the logistics of how you operate, a bit like a chessboard or a Go game, and the design, which is more the aesthetic side of things. And certainly in terms of the urban planning point of view, I know that urban planning is a huge topic in India, and it's possibly because you guys are so good at chess that you can relate to all this, right? And it's in this area that it's coming up with these things. But that was one comment. The second comment, which is, I think, is really hugely important, is this observation that developers are saying, we want you to use AI. The clients are requiring that. And why are they asking that? Well, one obvious reason. It's to guarantee the maximum return on investment. Clients want to make the most out of their plot of land, and AI will tell you that. So I can see that it doesn't take much to see, right? I mean, everyone can see this, but what's going to happen? Essentially, initially AI is there a bit like spell check, or whatever. It could correct us, make us aware of certain things, and that's helpful. And eventually, it becomes more and more, full of potential, to the point that it will know exactly what we like, just as Spotify knows what music we like, and Amazon knows what books we like, and so on. And it will know, based on our previous history, just as Gmail can finish off our sentences, it will know what we like, and eventually we'll reach the point where AI will be able to generate buildings completely autonomously. And this is, in a sense, the dark side, because it's a bit like self-driving cars. Once you have a self-driving car, you don't need a driver. And once you have an AI autonomously producing buildings, you don't need an architect. Well, maybe you do, a few, but anyway, that's the point, right? This is going to be the game changer, the absolute game changer. And I would predict that just the next stage is going to be, I think that a bit like sustainability, we are going to, let me just play the video run. We're going to find ourselves, architects falling over themselves, say, I am more sustainable than you are, I'm more LEED certified, and then it's going to lead to, I am using AI more effectively than you, and so on and so on and so on. And then the next stage is going to be AI is going to take over. And I won't go into that now, but that's the writings on the wall from that point of view. So I want to go back to here. I want to just open up the question about how we can maybe make comparisons between the sort of things that happen in the computer or through artificial intelligence and human intelligence itself, whether we can learn anything about the way that we think, or the way that the mind of the architect operates in the mirror of AI. And here I'm showing you some more recent work of Refik Anadol for Arctic House in New York, where he produced this project called Machine Hallucinations. In fact, it's based on images of buildings in New York, and I won't go into that now, but it's basically, what I want to point about is the term hallucination as a concept. It's a term that was being used by many people, well, a few people, should we say, before in the world of AI, by Blaise Guiriakos, as a way to describe, rather than dreaming, the term hallucination is being used. But the question I want to ask is, how can we connect these hallucinations with human hallucinations? How can we read into artificial intelligence, or out of that artificial intelligence, maybe gain some inkling or some insight into human intelligence itself? How can we learn also maybe about questions of creativity by thinking about what can be generated by AI? So now, of course, Refik could use the term dream and the term consciousness and the term memory and so on for his project on the Walt Disney Concert Hall by Gary. And it's clear there's a difference between humans and AI. That's not the same. Machine learning is not the same as human learning. The important point is that AI doesn't think. It's not aware. It's not sentient about what it's doing. And if it can't think, then how can you really use the term learning? And how can you really use the term intelligence? It's quite difficult to think of the right ways, of the right terms. And the term hallucination has been used, but how does it relate to human hallucination? So here I want to refer to, I don't know if Anil Seth's known in India, but his father came from India, right? He came from India in the 1960s, I think it was, to come and study in the UK, and married and settled down. And Anil Seth is now a professor of neuroscience in University of Sussex. He's working very closely with Andy Clark. I don't know if you know Andy Clark. Some of you might know his book, Natural Born Cyborgs. But the two of them are working on the same principle, which is to say, the principle of predictive perception. This is the book that he's just published. It's an absolute complete hit. It's on all the I think it's the top 10 books of the year from last year. It's got rave reviews, and it's basically a book about about how we can understand the consciousness and how the brain operates through, to some extent, the lens of AI, because Anil Seth did a PhD on AI before he moved into neuroscience. And what I think is super interesting is how these two domains are coming together. In other words, there are neuroscientists who are being trained in AI, who've got some background in AI, such as Anil Seth. They're also AI specialists, such as Demis Hassabis or I'm blanking on names here, Jeffrey Hinton, who are now very famous in the world of AI, and they also had a background. Demis Hassabis did a PhD in neuroscience. The key question is not artificial intelligence; it's intelligence. Both of these people, both these groups, are both looking at the question of intelligence itself, and that was one of the conclusions I came to in my book. And it's borne out, I think, also by, I would say, the work of Jeffrey Hinton, 1,000 Brains. He's going to be on Digital Futures in a few weeks. Amazing guy. And it's basically, this book is 1,000 Brains. It's called A New Theory of Intelligence. It is intelligence they're interested in, not artificial intelligence. The term artificial intelligence is somewhat problematic because it's not really artificial. It's synthetic, maybe, but not artificial. Anyway, so Anil Seth, I can recommend this. I also, for those of you who can't afford the book, I recommend having a look at the TED Talk. This is an old-fashioned, this is a screen capture from some time ago, because he's now got 12 million or so views. This is one of the most interesting and impressive TED Talks you will find. And he lays out basically his theory of consciousness as a form of hallucination. Now, what does he mean by that? Now, I can't show you a clip of TED Talk because I'll get contravened the copyright again, but let me just show you some still images of this. So first of all, let me say that the key question for Anil Seth is the brain is in this bony skull. It doesn't actually have any interaction with the world outside, except for some rather imperfect electrical signals that are coming through. And the question is how the brain makes sense of these signals. How does it understand the world outside? And the common perception, of course, is that the brain just, we absorb things. So we're a bit like a camcorder. We can record what's out there with the sound, the images, the smells, and so on. And we have access to the world outside, and it's not problematic. That's the perception that is out there. But more recently, people in neuroscience are beginning to realize that actually that's not how it happens at all. So let me just go through the arguments that he puts together here. So it challenges all this, puts the brain basis of perception in a bit of a different light. He's challenging this idea that we just simply passively receive the world and record it. And what he's trying to argue is the brain takes part in this operation in trying to make sense of what is out there based on these electrical signals. And what it's basically doing is it's hallucinating. It's trying to interpret it, offer its best guess based on what it knows about the world already. Instead of perception depending largely on signals coming into the brain from the outside world, it depends as much, if not more, on perceptual predictions flowing in the opposite direction. What can I see out there? What can I see out there? It doesn't know anything except what it's been trained to look for. And that, I would argue, is how we human beings also operate. We don't just passively perceive the world, we actively generate it. The world we experience comes as much, if not more, from the inside out as from the outside in. And this is the crucial point. If hallucination is a kind of uncontrolled perception, then perception right here and right now is a kind of hallucination, but a controlled hallucination. I mean, what's happening basically is our perceptions of the world are being or hallucinations are being reined in. There's I forget the term now that was used, but there's kind of feedback, that's a bit like back propagation, which is saying, is it right? Is it right? Is it right? Is it right? And the whole time there's a hallucination. Could it be this? Could it be this? So we're talking again a little bit like the way that the GAN operates. It's been questioning it. Anyway, the idea that perception is a form of controlled hallucination is fascinating. And this is not just him talking about this, has become kind of mainstream. It's a fundamental important thing. I will just say by way, because this is not really a talk about theory, but this is also some of the way that we understand the world through the lens of psychoanalysis. This is Slavoj Žižek, the most terrifying person in the world. So this is me in a roundtable discussion in Zagreb with him. I was terrified because he's so smart. He gave a talk on digital futures last summer. And if you take a Lacanian view of the world, we don't see reality. We never engage with reality. We see it through the lens of fantasy. Now, typically we think there's fantasy and there's reality. They're two completely different. But in psychoanalysis, we see reality through the lens of fantasy. We effectively fantasize the world. The world comes to us through the maze of the imagination. In other words, don't talk to me about reality, right? Don't talk to me about reality. Everything is somehow virtualized, which leads Zizek to come to the conclusion that essentially that what virtual reality teaches us is not how virtual reality itself is, but how virtual our own understanding of reality itself is. Let me say that again. What virtual reality teaches us is not how virtual reality itself is, but rather how virtual reality is. In other words, our understanding of reality is filtered through our imagination. The ultimate lesson of virtual reality is the virtualization of the very true reality. This is, so I'm not going to talk, there are many other people talking about this. I would also say that there's a book by David Chalmers coming out called Reality Plus. He's a philosopher who worked with Andy Clark, and he comes to exactly the same conclusion. Reality is highly, highly questionable, or at least our perception of reality. So I want to kind of finish off in a way by talking about how maybe we can use AI to understand how we as architects operate, or at least how the human mind operates. And so let me, so the idea of predictive perception is basically that we see the world in the way that we've been trained to see the world, just in a sense as a neural network is trained to see the world. So let me give you an example of this. If I'm sure it's the same in India as it is in the UK, as is in the States. Ask any kid at any school how many colors there are in a rainbow, and I guarantee, well, unless they've got parents who like Anil Seth, I guarantee they're going to say 7. I guarantee they're going to say 7, and they're going to recite them: red, orange, yellow, green, blue, indigo, violet, because that's what they've been taught at school, and they get 100%. They say that. If they get 6, they don't get. We are trained, and one could even say indoctrinated, to think that there are 7 colors in a rainbow. We are culturally constructed, shall we say, to think in that way. How many colors are there actually in a rainbow? Well, this is a rainbow, right? I mean, there's a spectrum. There's an infinite spectrum of colors in a rainbow. So why do we think there's 7 colors in the rainbow? Because we've been trained at school to think that way. The same thing happens for architecture. If you ask an architectural student what is a functionalist building, they will probably come up with this, something like this, Villa Savoye by Le Corbusier, a building on Pelotti with a flat roof. Well, if anybody who's has ever studied in London, in the UK, knows flat roofs in England are not very functional because it rains a lot and flat roofs leak. So there's nothing functional about a flat, but we somehow have this discourse. So in other words, we are also indoctrinated, trained to think in this way. So let me show you the work of Memo Acton, who is really one of the most interesting AI artists and thinkers. He's an amazing person who has basically taken the work of Anil Seth and tried to experiment using neural networks to see how that happens. Now, what's happening here on the left-hand side, you can see Memo playing around with car keys and chargers and so on. And on the right-hand side, there are a series essentially and cloths. There are a series of there are 4 neural networks here that have been trained on different sets of images. So this has been trained on the ocean, on the sea, on rocks. This has been trained on fire, on on a coal fire, and this has been trained on flowers, and there's also one that's been trained on clouds. And what's basically happening is that we are seeing the image on the left-hand side filtered through the lens of a neural network. So it's interpreting these things, this charger that comes out as some rocks and so on, through the lens of that. And that is essentially the argument that's been made by Anil Seth, that's articulated through Memo Acton. Now, what does that mean for architecture? I had a student who at FIU, and we were literally looking at this Memo Acton thing, and this is Fernando Salcedo 2 years ago, and he trained a neural network not on fire, not on flowers and the ocean and whatever. He trained it on Zaha Hadid images, in particular a building, which is a research center in Saudi Arabia, and trained the neural network on that. On the left-hand side, Fernando's wardrobe, a T-shirt or something. And what's happening on the right-hand side is that it's interpreting things through the lens of that thing. So here, there's another one which is based on generic buildings in downtown Miami. Fernando's tie turns into a tower block. This, to my mind, is absolutely fascinating. It seems to speak about a certain kind of architectural imagination, certain way of thinking whereby we as architects architecturalize things. I had a discussion years ago with Bernard Schumi, which essentially was saying, well, and we agreed that all architects see the world as architects. And my point being here is that we are trained to think in a certain sort of way, exactly as a neural network has been trained to think, or at least similar to, shall we say. So the term I've introduced is architecturalization. Maybe I should spell it with an S, the British way. And that, what is interesting about this is really, you think about it, how we're often inspired as architects by the outside world, and we incorporate some of that kind of material, that data, into the way that we design. This is an example at the Sydney Opera House. You probably know the initial sketch by Jorn Utzon on the left-hand side that was inspired by the billowing sails of yachts in the harbour of Sydney. And even though the final result, the final building, changed because of, for structural reasons, it's no longer this billowing sails, it's more a kind of a shell-like structure, but nonetheless, it was inspired by that. And this happens again and again in architecture. We somehow draw upon information from the outside world and incorporate that into how we express ourselves. What I find most interesting, though, is not so much the physical side of things, because that happens the whole time, I'm sure. We get inspired by forms, by natural forms especially, and so on, but how concepts operate. So Gilles Deleuze produced this book called The Fold, Leibniz and the Baroque, and very soon after it was produced, Greg Lynn produced this guest edited an AD, Folding on Architecture. Actually, Deleuze was not talking about physical folds. He was not talking about physical form at all. He was talking about subjectivities, the development of subjectivity. It was a philosophical. He's interested in ways of thinking, not interested in form. Nothing in Deleuze is really about form as such. And yet architects automatically, they see the word fold and they imagine folded forms, Maya programming and pleated matter and so on and so on and so on. And that, of course, I'm getting some stick for teasing these guys at the Bartlett, but it happens at the Bartlett a lot, right? I mean, Gilles Retzin reads that the digital is discrete. Well, it is, but then he kind of takes the word discrete and starts producing a language of discrete forms, which I find utterly banal, but interesting in its own kind of way. And then also at the Bartlett, Mario Carpo, in the second digital turn, he's writing about big data, and he reads that big data is messy. And therefore, he thinks there must be a style of big data. And he shows this image, also actually a chair by Manu and also by Gilles Retzin, and said, this is the architecture of big data. It's messy. Well, actually, if you think about big data, what we're talking about is not form, but information, informational processes. And if you think how an Uber car relates to a taxi, I mean, what's happening basically is that the big data and use of AI is not actually changing forms, it's changing the way that we process information. If you think about an Uber car, Does it look any different to an ordinary car? No, because it is an ordinary car. There's nothing about this that changes. But what changes is the way that you hail a taxi and so on. It's completely changed through the processing of information. And yet we architects automatically turn this into a form of architectural form. And of course, the ultimate of all was that it was Jacques Derrida and his concept of deconstruction. What Derrida means by deconstruction is exactly what I've been talking about. Exactly the rainbow. We have and he's talking not about architectural forms, but about constructed ways of how we see the world. He's interested in a way how biased we are, and of course it's coming out in AI more and more, how typically the kind of, he refers to the privileged hierarchies within Western metaphysics, by which he means how we tend to privilege male over female, or practice over theory, all these kind of binaries. There's always one term privilege over another. And he's saying we might have to go overcome all this privileging. We have to overcome these biases and try and understand the world as it is. And he does use an architectural metaphor for this. We have to dig down, we have to get beyond all this, dig down to a solid foundation where we're not biased in any way, and on the basis of that, then build our argument. So there is an architectural metaphor on there, but he's not talking about architecture. But of course, as soon as architects see the word construction, they immediately think he's talking about architecture. When I first started teaching at University of Nottingham, a student came to me. He was doing a thesis on deconstruction. This is in the 90s, right? And the term was had just arrived. And he was assigned, before I arrived, he was assigned the construction management guy. He said, I don't know why I've been given this guy to do a theory thesis, but this is the point. We automatically think that Derrida is referring to construction. He's not. He's referring to ways of thinking. Anyway, so there is a danger, of course, of reading into the kind of the world of AI human values. There's a danger of anthropomorphizing that world. And I'm showing you here an experiment that was done in the 1940s. I think it was really interesting. And it was done by two psychologists, Zimmel and Hauder, who basically tested out this video on this experiment on a control group. Everybody thought that what was happening here was that there's a story about a big triangle and a small triangle and a circle, and the big triangle is trying to bully the small circle, and the small triangles trying to come in to save the circle, and so on. We read meaning into this, but actually it was just shapes on a screen, geometric shapes on a screen. And there's a danger, therefore, of us anthropomorphizing the world of technology and reading meaning into it in a way, and there's a danger there. There's also a danger of the opposite. In other words, a sense of reading the human in terms of the mechanical, in terms of AI. And I want to be careful about that. Both of those are very problematic. At the same time, what I must suggest, I think possibly there is a we can use AI to open up questions about how the human mind might work, or open up insights or suggestions or glimpses, no more than that, because we're not proving anything. And and again, so the motivation for that is, for me anyway, is the idea that somehow the real potential of computation is to understand how the world itself operates. And this is an example. This is Craig Reynolds, who produced this animation, I think in the 90s, to model the flocking behavior of birds. Now, in order to model the flocking behavior of birds, you have to discover the rules of the behavior of birds. And I don't know how he discovered it, because you have to kind of reverse engineer that. But nonetheless, he produced this. This is these are called boids. And what is interesting is that up until then, nobody from the world of ornithology or bird studies, whatever you call them, knew how birds operated. But it was thanks to Craig Reynolds modeling on the computer that we began to get some insight into how that is happening. Now, that, to my mind, is exactly what's happening with AI, in the sense that even though there is a huge difference between AI and human intelligence, even though there's a huge difference between the neurons of the brain and the neurons on in a deep learning neural network. Nonetheless, curiously, certain properties they parallel one another, shall we say? So I want to go back to Blade Runner, to Rutger Hauer on the right here, who played Roy Batty. And tragically, he didn't live to see the moment when Blade Runner was happened. He died in July 2019, and before November 2019, when Blade Runner was actually set. He did, however, get to see Blade Runner 2049. He was very dismissive about the second movie. He said, I don't know why you need to make a second movie when the first one was so good. But anyway, he came up with a comment which I think is incredibly interesting about Blade Runner and about the replicants. In many ways, Blade Runner wasn't about the replicants. It was about what does it mean to be human? And this is the key question that I want to be asking and continue to ask. And I don't know the answer yet, but basically, how can we use AI as a mirror in which to understand human intelligence, human creativity, and to understand how the mind of the architect operates? I've not proved anything today by showing you that image of Zaha of being architect, or someone's clothes being architecturalized and turned into a Zaha building. That doesn't prove anything at all, but nonetheless, it's highly suggestive. And this is a final comment I want to leave you with, the idea that comes from an exhibition that was at the Barbican in London 2018, I think it was, AI More Than Human, and a comment by Hiroshi Ishiguro, who is a Japanese roboticist who produces these kind of weird humanoid robots that are replicas of human things, of human beings. And he makes a comment, the robot is a kind of mirror that reflects humanity, kind of mirror that reflects humanity. And by creating intelligent robots, we can open up new opportunities to contemplate. I think that's the key word, contemplate what it means to be human. Can AI become a mirror in which to understand the mind of the architect? And as a final image, let me just show you this. This is the work of Edward Hyman, who is a Russian architect teaching at Mark, and before that at Strelka. This is the Endless Tower, Infinite Skyscraper. I've forgotten the name. It goes on. And it just shows you the kind of creative potential. And he was responsible, I should say, also for the image on the poster for this talk, the kind of creative potential this domain is opening up. I have always thought, I had a discussion with Lars Hesselgren from KPF in the AA bar once, and he said to me, I have a theory that there's a tribe of computational geniuses, two tribes, one in China and one in India, and my mission is to find them. And I want to say that kind of like I don't, every time I meet an Indian, I keep asking, why is it you guys are so good at computation? Because it's not just Sharjah, right? There's a whole bunch of people who work on computation from India. I'm just blanking on his name now, but the guy who was behind Gary Technologies is also from India, and so on. And it seems to me that not only am I waiting for this revolution, computational revolution in India, and it's kind of perverse because Indian architectural culture is strangely not computational. It hasn't been, but thanks to Bavlin and others, it is going to be, that's for sure. But I'm also expecting, waiting for that tribe that Lars is talking about of Indian architects who are going to be working on AI. And I know one of them, right? Maya Mistry, we've already mentioned him. I'm convinced that in the future, India is going to play an enormous role in Samir Kashyap, that's the guy from Gary Technologies, going to play a very important role in introducing AI and be part of this in the world of architecture. There's absolutely no question. So let me, rather than get dizzy watching this, I'll just maybe go back to Giovanna Pelaka's video. And that's it. This is, I think, my thoughts in progress. I'm not claiming, just to make clear, I'm not claiming that I have proved anything. But what I'm saying, to float out there's the idea that maybe we can get some insights in the mirror of AI to how we operate, and that, to my mind, is also one of the fascinating aspects of this new domain. It's opening up theoretical insights alongside creative possibilities for the world of architecture. So let me leave it there and open up to questions if there are any questions as such. I hope that was clear.
Neil, I think that was very, very interesting. Thank you so much. I loved it, actually. I mean, I'm hearing this after many years. I mean, after being at the AA and stuff that was happening there about 2 decades ago, and this does, I mean, sound very familiar and very different and very engaging all at once, and it's fantastic, I think. Yes, I think Pavleen, if you want to kind of curate the next session.
Yeah, I think, yes. First of all, Neil, thank you so much. This was so engaging. This was so eye-opening to so many questions that we've been kind of addressing on so many things that were confusing at times. And I'm sure this session has given a lot of notes for students also to refer back to. And I'm sure a lot of people might be wrapping their head around the session. But if you guys have any questions or any comments that you would like to ask Neil, we have him around. Please use raise hand and we can have the questions. I just wanted to mention that we do have some guests that are joining from different schools in Mumbai. We have our faculties who are here, and this is also one of the sessions that we are beginning this year with. And I'm sure we are going to have you again and many, many, many more sessions. So if anyone has any questions you would like to ask.
Maybe I can just say one thing, and that is to say, I hope you are confused. I mean, or it's rather, I hope that your perception of what the world is like has been destabilized and called into question. And I think that's the important thing. In fact, that's all theory can do. Theory is not there to be a manifesto for some position. It's about asking questions and challenging assumptions and so on. And that's what I learned from Derrida. Is absolutely, theory is about challenging assumptions and popular beliefs. And if the work of Anil Seth can question our notion of what reality itself is in some senses, I think we can use this domain to question what the nature of architecture is and how the mind of the architect operates, because I don't think it's innocent. I think we are in many ways conditioned like a neural network to think in a certain sort of way. But I think we've got to change our mindset, I think, because this is happening. And I just want to say something maybe about the future. I mean, I think those of you here today who are educators, I think one of the primary responsibilities, shall we say, of an educator is to be aware of how things are going to be turning out in the future. One of my criticisms of architectural education is that we tend to look at the past the whole time. I say this as somebody who translated Alberti. Alberti was a revolutionary. Just be clear, he was a revolutionary. He was someone who helped to introduce the Italian language. And everybody kind of nostalgia look back and thinks this is how we should do things. He was questioning absolutely everything in what he was doing. And I think we should be very careful not to look back on this kind of, there is an obsession about history. And I'm not against history, don't get me wrong. I think there are lessons to be learned, but we also need to look at the future. The future is also connected to the past. There's a lecture that Wolf Prix gave, and the title was something like, "In 2 days, tomorrow will be yesterday." Or you could even say, tomorrow, today will be yesterday. We are connected in some ways, and I think we need to, as architects, really think about the future, because everything we do potentially is for the future. It's premised on the future. Every design potentially could be built in the future, and yet I don't know many schools. I think I would probably say that one of the few people is someone like Liam Young, who works in SIAC, who was at the AA. I don't know if I remember him, but who talks about the future. But we should be talking about that. What I find astonishing is the lack of engagement by the architectural community with these ideas. You know, when I started my research, I was looking around for buildings about the future. I found a book that was like the future of architecture in 100 designs or something, you know, and it was looking at certain sort of designs that that's going to be influential. People are going to copy that and so on. That's not the point. It's not about we need to focus now less on form and more on informational systems, and be looking at how AI and other forms of computation are going to be changed the way that we operate. And so I think we've got to change our perspective on things, and it's super important right now, especially for the generation of students who are coming out, because you guys are going to be at the peak of your career precisely when all this really kicks. It's already kicking in, but it will in 10, 15 years time. In fact, by the end of this decade, I would say every single discipline will be teaching AI. Every single school of architecture will be teaching AI by the end of this decade. Something similar was said by Bill Gates in 2000. He said by 2010 there'll be nothing that will not be somehow conditioned by the world of computation. And I would say by 2030 there'll be nothing that will be conditioned by AI. We need to kind of think about that and plan in advance. In other words, just final comment. The one thing that students of today need to design is not a building, but their own future, and be aware of the conditions in which we're operating, and try and plan out a path that will engage with that. But I hope you're confused. I hope you're shaken up and disturbed in some ways.
I think in many, or in some ways, I think whatever you call it, a hangover from coming from the A and the Bartlett, you know, and coming into the school. I think we've had very interesting and similar questions that we start off with the students in some of the studios, you know, where we actually we really look at nature and kind of learning from nature in a big way. I mean, we look at you know, emergence and self-organization right from the first, second year. We start to kind of throw these words out and kind of so-called confuse the students with ideas, you know, relating to complexity. And how do you decode these, you know, through diagrams, through models, you know, and kind of find structure, find meaning, find geometry, find patterns of interrelations between different elements. So I think these are kinds of questions that, at least here in the school, we do ask, you know. And then in the kind of coming years, in the senior years, we also try to kind of shift the focus from nature to city, and we kind of start to draw parallels. We start to see how the city itself is also has the same kind of elements of complexity that are kind of overlaid, and how do you maybe find ways to decode. So things like you know, cellular automata or self-organizing systems or things like that are somehow getting introduced very early on, and even sometimes in the later years we revisit them while observing, analyzing, maybe, you know, theorizing the world around us, you know, in some way. So I guess, yes, it's good to kind of the word confuse is kind of good and bad, but it's finding new meaning. I think, and it does happen. Yes.
Yeah, I think the AA is kind of a very interesting place. I think there were two golden moments in the AA. One was, I think, back in the, I guess, 70s, 80s or something, when you had people like Cedric Price collaborating with John Fraser, just beginning to produce the first forms of what we could call interactive architecture in the Fun Palace and so on. And alongside that, there was REM, and there was REM teaching Zaha. That was one golden moment. And I think there was another golden moment when you were there, actually, when at the beginning of the 21st century, sorry, the 21st century, when, I mean, I was teaching Akim Menges and Neri Oxman were students. They were students there. And of course, Akim was 1 year ahead of Neri and taught Neri for a final year. But that was amazing. And I think all that emerged, especially out of the AADRL and its impact, I mean, the historians of the future will look back on that as a kind of a moment. And I remember when Brett commented on the 10th anniversary of the AADRL, he said, well, you know, it's not typical for an organization that is premised on the future to look back on things. And, you know, but when we do look back on things, I mean, you could say maybe things have shifted to the Bartlett now because Bartlett poached many figures who came from the AA. And I hope that the AA kind of reinvigorates its process. But for sure, a lot of things emanate from that. And the AI, I would say, was really interesting from all sorts of aspects. But the one thing I find incredibly interesting is that it was kind of deterritorialized. In the sense, it was deterritorialized both intellectually, in the sense there were people there. I mean, Mark Cousins, just unbelievable, powerful intellect. Talking about Hegel and Freud, and he wasn't an architect, but he was really stimulating debate in some ways, and he was deterritorialized in terms of the kind of theoretical things and so on. But it was also, in a sense, almost like, I don't want to say physically, but I mean, it was in London, but it wasn't in London, right? Because no one there was British. I taught there for 3 months. I didn't have a single British student. And then, of course, they go there and they go to Saha's office. And at the time, I remember there were once 6 people in there were like 300 or 400 people working in the office. And 6 of them were from the UK, mainly most the secretaries. And it's that sort of, I think, almost in a way, that is a model to deterritorialize the mind itself, to open up to new possibilities. That's really, I think, what the AA taught us is, and of course, it's been so influential and so impactful in many ways. So yeah,
I'm sure. I think the students, I think a lot of, or rather some of these things are things that probably might have even had readers. I mean, Stephen Johnson or Kevin Kelly, and these are guys who we kind of throw at them very early on. Figure out what a hive mind is, figure out what an anthill is, and things like that. I mean, are questions that they really ask in at times, even conduct good research, deep research in these things. I mean, guys, if you guys want to ask some things today as well.
Yeah.
Open, yeah.
Comment on this before this. I mean, Stephen Johnson's book, of course, came out on the day of 9/11. When I was teaching there, everyone was talking about emergence and swarm intelligence. Everybody, literally everybody. But I would say now is all the figures who are working at the time of multi-agent systems, like Elisa Andrzejczyk or Roland Snooks, or even Casey Rees, they're all doing AI now. It's a shift. I mean, that seems to be the kind of the shift from swarm intelligence towards artificial intelligence. Also, of course, Daniel Bolajan too. So that's become the key thing. And I think the real problem about swarm intelligence and about emergence was what level of intelligence was in operation. It was pretty basic, pretty straightforward. I mean, the slime mold is intelligent, sure, but but this is the other domain. It's opening up, and I think the kind of what I was just saying before, the kind of challenges is that AI operates at a level we can't comprehend, and I think therefore we have to go through what I wrote about this before, and it's not other people use the concept of a second Copernican revolution. In other words, if Nicholas Copernicus taught us that basically, or told us that the Earth is not the center of the universe, actually the Earth goes around the sun, we've also got to recognize that we are not the center of the universe in terms of our intelligence. There are entities out there with far greater intelligence. Just as anybody who owns a dog, or anyone actually, frankly, would know, dogs have a greater range of smell or hearing than human beings. So, I think we've got to recognize that. And frankly, if we all die out of COVID, the universe will carry on without us. I mean, we're not that important. Yeah. Anyway.
Yeah. I think another question which kind of emerges for me also is that I think we had a very interesting discussion in the Digital Future session on Office of the Future, where Vanyu and Spacemaker we were discussing. It kind of also brings me to the question, then what would be the schools of the future or architecture schools of the future, which is quite interesting. That then how do we shape shift the curriculum? How do things kind of emerge from here for us? Which is quite interesting. That do we start talking about neurosciences, or should we talk about consciousness more? So
well, I think there's of course there are those questions, and I think that's important. But even there's also another question about the structure of operations. I mean, what became very clear with COVID was that the future, which we've been speaking about this, the digital, but suddenly we were fast forwarded into this kind of domain. It was possible to order things online. It was possible to have a Zoom conversation. It was possible to have contactless payment, all these kind of competition things, but we were forced to do that in some ways. And it kind of, that shook us out of our familiar routines. And I think one of the kind of key questions came up, and this goes back to the way that the kind of second phase, as it were, of digital futures operated, is that we had been meeting in Shanghai every year and having a physical conference, and everyone would come, and it was great. You know, Shanghai is a fascinating city. And so Philip Yan and I, we were in 2019. I actually was due to fly to China. My flight was cancelled because of COVID. And we said, we can't do anything. It's impossible. We'll never be able to meet up. This thing is going out of control. And then I was sitting here actually in the same space I'm in now. And I began to realize that, you know, I had a review from my students at FIU, and I invited critics from, Wan Yu was on the thing, Philip Yan was on, and then there was people like, you know, from London. There were people from all over the world, and you could operate, and suddenly this space of possibilities opened up. And I guess from there, you know, I think that it's become clear that that this affords all sorts of possibilities in terms of bringing together certain minds. And I kind of use the term global brain sometimes, because almost like you've got all these minds within a space, a kind of thinking happens which you never get otherwise, a very immediate feedback between these the kind of the neurons, as it were, and some astonishing approaches, astonishing ideas happen and are germinated by that process. But the point is, we don't actually need some of the protocols that we had in the past. And one thing I think opens up is the possibility of using this platform as a way of sharing information, which is really behind the Digital Futures Initiative, is to say, well, no, how can we share this information? You know, the idea that there's a single professor in a single classroom talking to a single group of people, we could just have on the same platform and have, you know, Akim Menges talking about something, and Grazio Cola talking about something, and Daniel Bolajan and Roland Snooks and so on the same kind of platform, which means that, you know, we need to rethink of the logic of what we're doing. And I think that there are all sorts of possibilities there that I think are important about how we could reconfigure architecture beyond the physicality of what we're used to. And it goes back, in fact, to the European Graduate School, where I set up a program which sadly is no longer going, but it was a fantastic program for a while. And we had John Fraser and Akim Menges and Sanford Quinter and so on there. But what was interesting about that is it was completely deterritorialized, completely nomadic. We would settle almost like a butterfly in a little village, Saas-Fee in Switzerland, once a year for 3 weeks and have these incredible conversations. Well, if you set up a school of architecture now, the first thing you would do is not have any buildings, because buildings are expensive. You've got to pay for the maintenance for about, you know, and so on and so on. So we have to really rethink that possibility now. This new domain has opened up, and we're a domain that was there before we hadn't really recognized. Anyway, there's a longer discussion there.
I think we have few questions coming up now. I just like to invite Gia now to just unmute, and if you would like to ask question, and then Mugdha followed by Said.
Yeah. Can you hear me?
Yes.
Hello?
Yes, we can hear you.
Yeah.
Yes.
So I had a question, which is basically, so I was also studying on a thesis with Atresa itself, wherein we were creating like speculations and narratives for the future to then begin to start imagining how the build form should be. And this was like a year ago, but I still have this question like ongoing in my mind, which was something which did reconnect again while I saw your presentation, which was that what AI does is forms a speculation of the possibilities which are possible. But then how do you see, like, what is your opinion, like, as to how do you see these speculations coming to reality? Because there isn't one sure shot possibility, but a million of them, again, thanks to AI. So then how do we actually test them in reality? Like, it's a confusion again, but I'm just intrigued as to how that actually happens then.
Yeah. I lost a little bit of that from the reception. I hope you didn't lose much of me from the reception. Well, I don't know if you say tested in reality. I'm not quite sure what you mean by reality. I mean, I've been suspicious of the term reality ever since Coca-Cola advertised itself as being the real thing. But yeah, I mean, I think that the question about performance is written into the potential of computation, in the sense that, you know, when I was a student, we didn't have these models. We had a kind of wind tunnel or something. You know, you could just test things out in the physical thing, and you didn't know. But if you're working with software that's already kind of performative in some senses, you're automatically generating something that should work. So I think that's the point, is you should be able to generate things. And I mean, if we're talking here not just about kind of like structural concerns, because there are any number of programs now that are looking at topological optimization, which are used for structure, but also for environmental concerns, programs like infrared and so on, that we now we know that what we're producing, if we use computation, will perform. But in some senses, I think there's this issue about, I mean, because you can produce multiple potential options in using which one do you select, and which of course it's the way we take photographs these days. So the idea of the past that you would set up the perfect photograph, and you might have a kind of a Polaroid, and you could take a sample, but you wouldn't know what you'd done until you got you process the film and so on. So, but now it's different. We take a bunch and we kind of sample, as it were. We take hundreds of photographs, and just select the best one, and then kind of filter it and condition it and so on. And we then, but it's a different way of operating. And I think what I would say is that, we have to start developing a different sort of language, shall we say, of what we're doing. What I found interesting with the session with XCool is that they would use the term generate. Well, let's generate this, we'll generate that. Not design, it's generate. And I think what I would say is interesting is that what AI does largely is to search. And maybe the term that what we're looking for is, what you do in terms of creativity is you establish a kind of search space, and then you unleash these algorithms that will look for the possibilities about it. And if there's any, that's where it's happening now. So it's a different mode of operation. So we maybe have to change the verbs or the terminology that we use. We're not talking about design so much as outcomes, and so on.
Yeah.
So I don't know. I'm not sure what the answer is to your question, but I think this is something that deserves to be explored, and we need to explore it in a slightly iconoclastic way that is really kind of challenging what we thought was the answer before.
No, I totally agree. I mean, the point of asking you was technically asking your opinion as per it, because I do understand there's no short answer to this. It's still like you're exploring. So I do get it. Yeah. Thank you.
Yeah, thanks.
Yeah, Mugdha, you want to go? Yes.
Yeah. Hello, Neil. Thank you so much for this wonderful presentation. The way you talked about reality, it's very interesting and intriguing in a way to, discuss reality also. I also want to kind of draw a parallel when we talk about Indian philosophy and spirituality in general. It always questions this nature of reality. The constant question is, what is reality? And, then there are multiple interpretations of reality, and how do you perceive those interpretations of reality? So, it actually the whole theory stands around asking continuously and constantly the question about the nature of reality. And so to say, even in, how it translates into architecture, especially because you showed certain clips about where the temple architecture has been referred to. It was very interesting because the whole nature of temple architecture also is based on not the experience, or rather not the reality that you see outside, but seeking the point of experience. I don't know how to elaborate on that, but definitely it's about the perspective of an experiencer. So how do this parallel exist in AR when you're talking about the point of view of an experiencer rather than changing of multiple realities?
Well, let me just simply say that first of all, that and I back in the 90s, I produced a book, 99, a book called Anesthetics of Architecture, that was based on the work largely of Walter Benjamin, but also Jean Baudrillard. Because Baudrillard is famous for questioning our notion of reality, and this term hyperreality. I mean, now, according to him, we live in this world of a third order of simulation. the image has become so dominant that it is our reality now, and so on and so on. There's his concept of hyperreality. This all came from Nietzsche, and Nietzsche got it from Eastern philosophy. So it does. There is a connection there that is well known. I guess the kind of question that came up with anyone who's seen the Matrix, which I mean, the Baudrillard's point about the Matrix, you can't step out of this simulation in which we are operating. But what I find the limitation of that kind of viewpoint is that he talks about how we progressively got into this third order of simulation, and it happened in the late 1980s, according to him. Well, that's wrong, it seems to me. What's happening, basically, we've already been operating in a simulation. We have a model of the world in our brain, and it is part of how we think. So that's what it's telling us, I think that, I mean, it is, in some senses, you're absolutely right. There are other issues as well. I think Plato's cave and so on, about how we question reality itself and so on. I would just say that I think we're at an important moment in time when, from all sorts of angles, we're questioning we're addressing the same question and coming up with interesting answers. Again, part of this, I want to mention that we have this as part of Digital Futures. We have a doctoral consortium session starting in a couple of weeks, where we are exactly looking at this kind of question. And it's so interesting how all these neuroscientists and these AI people are telling us that reality is really not what we think it is. And so it's such a hot debate right now, and it's interesting that Indian culture, along with many other Eastern cultures, are already aware of those kind of questions. So all I could say is, we know this interesting, because I think, if you think about neuroscience now, I mean, what I like about neuroscience, it's not completely rigorous. I don't think any science is completely rigorous, but it's more rigorous, let's say, than psychoanalysis. I mean, when Freud was talking about the unconscious, he had nothing to. He wasn't proving anything. He was just speculating, and there was no proof anywhere. And now we begin to see that there are so many arguments that are coming in that are in harnessing some of these new technologies and new techniques and ideas, that we're in a much better position right now. I'm as a theorist, I'm really excited by all these things happening. It's not just the question of consciousness, which is automatically a philosophical question that we have to address right now, but all these other issues. It's I think, to my mind, it's one of the most exciting times to be a theorist at the moment, because we're shifting into something new. And what's, just in broad terms, what's happening is that back in the 90s, or even into the beginning of the century, we were talking about French philosophy. Well, philosophy has given way to what we call the cognitive sciences, which is to say neuroscience, AI, a kind of philosophy. If you look at the work of, say, Andy Clark, and you can see it is philosophy in some senses. That's what's happening now, and that's the shift in the debate. And I think the problem about philosophy, as Stephen Hawking's pointed out, is it fails to keep pace with technology, and we need to embrace technology. That's, I think, one of the key kind of problems. When I look back on the 1980s, when I was a student, it was all about history, about Tony Vidler and Kenneth Frampton and God knows what else, and we weren't engaging with the world of materiality of technology and so on. And it took someone like Manuel de Landa to start introducing debates about new materialism. We got beyond the kind of the poetics of postmodernism to understand a new set of domains. And I think that is the fascinating aspect of what's happening, is that we're engaging with the world of science and technology and theorizing it in a radically new way. So David Chalmers is an interesting character, because he was a mathematician. He went to Oxford as a Rhodes Scholar to do mathematics. He turned into philosophy. He reminds me of Wittgenstein, who was trained as an engineer and became a philosopher. What is, I think, is interesting is how we, as architects, having almost denied that for a long time, are now embracing the possibilities of what science and technology can do to feed into not just technical questions, but also ontological questions, philosophical questions about what the world is. So I'm sorry, I rambled a bit there, but yeah.
Absolutely. Thank you so much. I think, yeah, it's high time we start, debating about all these things. Yeah. Thanks for your insights, Neil. Thanks.
Yeah, Neil, if you don't mind, we have like lots of questions.
Oh,
So,
no, no.
okay. Atmi, you want to go next? Yeah.
Yes, ma'am. Good morning, sir.
Morning.
Hi. So my question was that you mentioned that it is dangerous to anthropomorphize AI and the other way around as well. And I want to know why. Like, why is it dangerous? Is it because it hinders with how intensely, like, our idea of reality is changing right now with the coming in of AI? Or is it because it's dangerously oversimplifying in some ways how complex these other intelligences are that aren't human and that are like synthetic? Or is it some other reason? Like, why is it that it's dangerous?
Well, it's not necessarily dangerous. I mean, the fact that you might call your car a name or something like that, I don't know if you do, but it's not necessarily dangerous. But I think we have to just be careful of conflating these two different domains. I mean, the technology is, how can I put this now? I mean, it is radically different. It's radically other, and people who start talking about robots in a cuddly kind of way, you misunderstand it, and so you're kind of deceiving yourself. I don't know. I mean, is it dangerous to anthropomorphize? I mean, it's only from an epistemological point of view in terms of knowledge. If you somehow assume that we can use these terms, and the difficulty is we do use terms that are similar. We use terms. Let me just simply say that I think the crucial question is that AI doesn't have consciousness. It's not sentient. That's not yet. Until we reach AGI, it's not that. So it doesn't know what it's doing. Your computer doesn't know. I mean, it can beat us at chess and Go. It has no clue it's playing chess or Go. It's got no capacity to think. No more capacity to think than your pocket calculator. AI does not think. And that's therefore if you read into it something that is human, as soon as we use the terms intelligence, as soon as we use the term learning, we somehow conjure up a human version of that. And therefore, I think we just got to be cautious about the difference. I mean, I think the other thing also would work in some senses is that, okay, AI doesn't have consciousness, but then we have to ask ourselves this question about to what extent we are fully conscious about what we do. I mean, I don't think necessarily the argument is that AI can't be creative because it doesn't know it's being creative. That's Melanie Mitchell's point of view. But I don't know if we're fully conscious of when we are creative. That light bulb moment when suddenly something occurs to us. I mean, even the term "it occurs to us" seems to suggest that we're not fully in control of it. I think that we do, in order to appreciate something, you've got to be conscious. So you might have this amazing flash of inspiration and say, wow, that's great, that's amazing. And that's where your consciousness is kicking in. But I'm not even sure that we're even aware of what is erupting, shall we say, in our minds, and that is the way that it could. It's not to say it's not happening. It's just we're not aware of those processes. The body doesn't tell us everything that's happening. There's a deliberate reason why we don't. It keeps us from the overload of information. If we were aware of everything our body was doing at the same time, we couldn't do anything. The body is very clever at somehow, we have an accident, it anesthetizes us. The other example is we can't even hear our own snoring. So it's kind of interesting, the body, how it operates. So anyway, we're not fully conscious either. So I think that maybe when I say dangerous, maybe that's an overstatement, but I think we just got to be cautious about the language that we're using and try and understand it for what it is. So it's not literally dangerous, but I would just caution people from doing that. And it's such a temptation. I think whenever we talk about any of these words, we automatically, just as we kind of architecturalize things, we kind of humanize things, shall we say? We kind of and that's the issue. So long as we're aware of doing that, that's okay. But there is a danger there. Does that make sense?
Yes, so but I think that if we consciously remove the humanizing, like if we try not to do that against like the natural instinct, won't that increase how much of conservatism is already there about like new technology, like as you mentioned in the beginning, right? Like there is some kind of antagonization of AI. Like if we stop humanizing it in so many ways, won't there be a sort of alienation? I mean, as you said, it's probably a good thing that there's an alienation, but still, like,
I don't see. I don't. The term alienation, I think, is problematic. I mean, this is a kind of, in sense, if anyone's read Heidegger, I mean, God, I was fed Heidegger at Cambridge, and I mean, he talks about technology in terms of alienation. I mean, it's not alienating for very long, and I think this is the problem about these concepts: is you grow into, adapt to, and you become part of the world around you. You assimilate, and that's really what my book Camouflage is all about. How we are adaptive creatures, and the mind is plastic, as neuroscientists will tell you. We adapt to the world around us. So. I think the concept of alienation, and of course that was behind much of the kind of anti-computational discourse that was going on. I mean, fortunately, it's died out. Literally, some of the people who were arguing it have literally died. But when I was a student at Cambridge, computers were banned from the studio. It was because it was alienating. So what happened was a whole generation of students graduated who couldn't get a job because they couldn't use the software that was used in the office. So I just think we got, but at the same time. So I don't buy into the alienation argument, but I think we've got to understand things for what they are. Shall we say? Yeah.
thank you, sir.
I think we can take up these last two questions. Jatin, would you want to kind of unmute? Yeah.
Hello, sir.
Hi.
Yeah, sir. So my question was that humans kind of think consciously and kind of have their output, and there are different ways through also like intuition. So pardon?
There's different ways, and you said what? Sorry, I lost that. Confusion or
no? People also think intuitively.
I
Is
see.
what I said. Yeah. So, like, does AI kind of have the potential to kind of think intuitively, which is like without kind of conscious reasoning, which is not even kind of random algorithm, but it is a kind of intuition which is like a deep feeling which humans kind of have. So, which is maybe connected to their past or maybe to their surrounding. And we kind of get these intuitions from many different things, from feeling things, from also smelling things, from our senses. So can AI kind of do that for design?
Yeah, that's a good question. I mean, I think well, you need to listen to this guy Jeff Hawkins, right? This guy, the Thousand Brains guy on intuition. I mean, I think that the danger of intuition is it kind of mystifies a process. It's actually quite a kind of, probably is a straightforward process. We're just not able to access what is happening. It's it's part of this thing, the body filtering or blocking some of these kind of thought processes that are happening. But it's kind of interesting how the body does produce certain things. I mean, I was trying to remember the name of Samir Kashyap. No, I said I can't remember his name, and then for some reason I wasn't even thinking about it, but it pops into my mind afterwards, and there were some processes in operation that were searching for that name, even though I'd stopped talking about it. It was in my mind, and I said that the intuition operates at that kind of level. It seems to me it's not that it's not there. It's not a kind of thinking process that we just kind of mystify it in some way and call it intuition. But I think it is a thinking process. It just we don't understand how it operates. And I think what's interesting about deep learning is it's exactly the same. It's exactly the same. We don't know how the hell deep learning works. We don't know the hidden layers. Nobody's got any clue. All we know is it works. I mean, for example, I don't know if you've ever tried these translation apps. I use WeChat the whole time, and it's actually very, very good. And the logic of deep learning, it keeps improving. Therefore, it gets better over time. But the Chinese to English translation on WeChat is astonishing. But how does it work? We don't know. And I think that's that's the interesting parallel between the world of computation and the world of how we think ourselves. We still don't know. And of course, we don't understand consciousness. I mean, that's the real challenge in sense of trying to get anywhere is, until you understand consciousness, how can you possibly simulate it or try to simulate it? I guess, so I would say that I mean, your question, I think, is opening up, really, I mean, AI is opening up these questions, right? It seems to me it forces us to think about these things. I'm not sure what the answer is to any of these questions, but I think it's important to start asking those questions. That's the real important thing about theory, is to ask questions. And yeah, so I don't know is the answer, but this is the astonishing thing about
Yeah.
the neural network that was, I just mentioned that it was so loosely modeled or inspired by the brain that
Hmm.
Melanie Mitchell refused to use the word neuron. It's the units, but yet it does emulate what we're doing, which is really surprising. It's really surprising. Yeah, that's what I could say, I think.
Yeah. Yeah, so like usually AI works on the basis of algorithm and inputs, right? So that is what the main idea is, that there's nothing which kind of comes out of it from within. Like it can't kind of create. It
No,
is.
no. I mean, okay, so I think you got to draw a distinction. The term AI is a big term, right? And it was coined in 1956 or something. And the problem is we still use it today. But what happened in 1956 is so different today. It's a bit like comparing a Model T Ford car, the very first, with a Tesla. It's and what we've got within that is a series of developments. And we started off with, basically, AI was kind of programmed, shall we say. It was called expert systems. But then it started what we call learning. I don't know if we could use the term learning properly, but learning systems are the ones that really started opening up things so it could do not just what it was programmed to do, but what it learned to do. And that's where we get the situation when AlphaGo produces things that we just couldn't imagine ourselves. So yeah, there are different areas of AI, and I think it's that learning system one which is the really fascinating thing right now.
Yeah. Thank you, sir.
I think this kind of brings to Karthik's question also. Karthik, would you like to just elaborate? I think it's talking about similar idea. Yeah.
Yeah. Hi, Neil. It's good to see you after a couple of years.
Your face is so the AA, right?
I was in IAC.
IAC. No, sorry, it's okay. Yeah.
Yeah, it's so good to have you here, and it's nice to just hear your lecture about your book and what you're exploring through your conversations at Digital Futures. It's quite enlightening and also brings me to a great confusion, which is great. I think my question overlaps with most of the questions that have been asked, and in general, is that if we would have trained intelligence and its permutations and combinations, would it merely become a tool for imagining architecture or design per se? Just like you mentioned, like how AI, we need to think of it as like a mirror of your own projections, like in the sense, if you're an architect, like how would you think, how would your intuitions work? So in that sense, is it important to just take some random images or data structures to kind of amalgamate these illusionary images, or like hallucinating images? And if that is so, then what happens in the third dimension, and what happens in the fourth dimension, which is the sense and touch and feel? I think these are questions which intuitively just come, right? Like you're not thinking too much at that moment, but like, okay, that's another tool that I have to adapt to or like come to.
Yeah, I'm not quite sure what was the question there. What was exactly? Give me one sentence.
So would these trained or trained intelligence be merely a tool for architecture or designing?
well, no. I mean, yeah, I just, we don't know quite how we will use our tools in the future. I mean, I think, this is it is a tool for sure. But if you think about when the mobile phone was first invented, the cell phone, they thought it was going to be for businessmen. They thought, okay, this is what was going to be used, and people are going. And of course, they had these massive, great, expensive things. But really, what happened was that it came of age when people began to realize that actually, well, let's say the businessman would lend the phone to his daughter or something and saying, give me a call when you want me to come and pick you up, and I'll come and pick you up. Suddenly, you might predict what you might want to do with something, but who knows how people are going to appropriate it and use it in new inventive ways. So I don't know quite what it's going to be used for. And I think, this is what is so interesting, is that that's why I like the work of Daniel Jovanovic and at SciArc, they just, all of a sudden, all these possibilities are there, and I think that's a comment that I think that it's made by Umberto Eco, this idea of the secondary use. You might design something for them, but then it's kind of appropriated in new kind of ways. I don't know what it will lead to, but that's the thing, is you're opening up this kind of Pandora's box of possibilities about how you could deploy these mechanisms in the future. And I think this is where the architectural imagination comes in some senses, of how you could use these tools. It's not just kind of defined in some way. So it becomes a prosthesis, as I see it, to the human imagination. So we become these cyborg-like creatures in a way that, Elon Musk has this kind of idea that we're all superhuman now because we have this extension of ourselves in our cell phone that can allow us to do things that are just way beyond what people in the past could do. There's more computer power in your cell phone there was in the entire Apollo 11 mission, and who knows what it will lead to. I don't know. It's interesting from that point of view. When you plant a seed of something, where does it go? I often refer to I was studied in Cambridge at Emmanuel College, and I remember when I was a student, there was an anniversary, the 500th anniversary, I think, of the founding of the college. And when it was founded, Queen Elizabeth I, 500 years ago, planted an oak tree. She planted an oak tree, and she said, I don't know what fruit will grow from this thing. And actually, a few years afterwards, there was someone called John Harvard who graduated from Emmanuel College, and of course, he went to the States and gave his name to Harvard University. And I often talk about digital futures in the same way. We don't know what it's going to lead to, but at least open up the possibilities and explore what you can do with it. And I think that's the same in the sense of this tool. I think that we haven't even begun to really explore its potential, but I think that is the interesting thing, is how it opens up the possibilities of thinking what it is to be an architect. And I suspect that also, just a kind of comment, I think it's not just the tool, it's the way in which we operate as architects, which is going to have to fundamentally change. And I think that, I think that there's something very special about the architectural imagination, for sure. We will be replaced by AI, for sure. Many of us will. But, if you think about it, our real problem in terms of architects, we tend to define architecture in terms of bricks on mortar. But actually, I think it's about a sensibility. It's about a way of thinking. I've seen, Benas Farahi was kind of interesting when she moved into the cinema school from architecture and did her PhD there, because they were just blown away by what an architect could do. We can design, we can think three-dimensionally, we can understand material behavior in a way that no other profession can do. And if you think about that, and you think about, well, how we can deploy this strange architectural imagination and use these tools, God knows what it would lead to. So I don't know what it will lead to. It just unleashes possibilities, and it's kind of an exciting time. And you think, well, what could happen as a result of all these things? So I don't know. But in some senses, what I would say is IAC is kind of interesting as a space, right? A space of opportunities, because IAC would not exist if every school of architecture did its job, and basically it doesn't, you know. So we have to have these supplementary institutions, the AADRL or IAC, that start introducing the tools that should have been used in architectural education in the first place. And hopefully, eventually, IAC will be cancelled out because every single school is like IAC and doing all these kind of things. But so, you know, I think we have to be creative and open to the possibilities, receptive of these things, and think, use our architectural imagination about how we can use this. I use the expression other architectures often to refer to this. When Azfari and I produced an AD on, we called it 3D body architecture, and what we were struck by was that fashion designers like Iris van Herpen were going to architects, were going to Nicola Casas, to people like, or indeed Neri Oxman and so on, to 3D print outfits for them, because we could do it, and we could do it. And I think, you know, one of the things we've got to get beyond is this narrow conception that architecture is just about building, because it's about many other things. You look at Greg Lynn, who's doing these kind of little robots that kind of follow you when you go shopping, or you look at I forget the name is now. Greg, he did the what's the movie called? The Tron Legacy. Tron Legacy.
Tron Legacy.
Yes, and so on. You know, and there are people who are 3D printing sugar, and they're doing all these these are all architects. You know, and you know, I think this. You know, I think we have to rethink what the term architect is. When I was years ago in Nottingham, the RIB asked me what the architect should mean. How we should define the architect, and I said, well, architecture is less about the design of buildings than about imagining a better future world. You know, and I think that, you know, well, I mean, I think the digital futures is itself an architectural project. It's, you know, it takes an architectural imagination to see those possibilities, perhaps, and move on. So I think we need, as a profession, to also mutate and develop and adapt, you know, to the changing world, and think how we can position ourselves, because I think we do have a future, because but it's probably not going to be the future we thought we had, you know. I'm not sure if I answered your question there, but it's anyway.
I thank you for answering the question in many ways, that it sort of also arrives us to ask like some real questions. And I think what I also observe, what's happening on the internet through YouTube videos and a couple of other forums, is that how the profession of architecture is also kind of reimagined, where an architect is no longer just building for the physical structure, but is also building just digitally as an experiential sort of imagination or spaces, which can simulate or stimulate a sort of a sense of feeling. Of course, I'm not going towards talking about metaverse, because that's just another universe altogether, but also the kind of possibilities which open up in terms of the digital presence of the physical objects. No, so I think what you've also kind of said is kind of making sense to me in terms of like the probabilities and possibilities, but also with an exclamation mark. So it's great.
Yeah, just, I mean, maybe one comment. Back in 2009, I think it was, I guest edited an issue of AD called Digital Cities, and Patrick Schumacher, that's where his thesis on parametricism developed. And I'm a little skeptical about parametricism myself, but nonetheless, you know, and he was kind of seeing the future in terms of this kind of parametric world of, as he puts it, of these kind of, you know, Zaha-like forms and so on, you know. But actually, the most interesting essay in the issue, and they're all doing the same thing, Tom Verabes and so on, and they're all talking about these will be the forms of the future. And what Ben Bratton did in the final essay, he wrote an essay called iPhone City. And he said, what's changing is this simple device, this iPhone, is changing our cities and how we navigate and understand our cities far more radically than any form is, you know. And he spoke about informational systems now as how we're changing, you know. And I think if you think about the city of the future, I mean, is it going to look like something out of the Jetsons? Is it going to look like some space age? No, and it's going to look pretty much the same. You know, I think Mumbai, London, all these cities, you're not going to demolish these buildings. You're going to get a few additional extra ones that kind of, maybe some of them are going to be pretty kind of futuristic, but some of them are also very nostalgic in some ways. But what we are going to see is that whole fabric of the city retrofitted with informational systems, AI-based systems that are completely going to change it. So that's in my book. I refer to these what I call brain cities. In other words, if we talk about, through the logic of emergence, of the city having a sign of intelligence, but a pretty low-level intelligence, once you harness AI as a kind of prosthetic device that can be used, or as a digital twin to monitor and improve the traffic, such as I mentioned in City Brain, what you get then is a kind of brain city, a city that is augmented. It has an intelligence, but it's augmented through AI, and that's really where it's going to come through. So I think that I think we need to shift our focus from form to the information, and think about informational architects of the future, and how you can harness these technologies to get the information that itself will feed into the logic of form. So in other words, if you take the word form, it's kind of interesting as a concept, because I think we're shifting away from form for the sake of form to form that is informed by informational processes or performance processes and so on.
Right.
So that's why I think where we're coming into, whereby we will have intelligent design, we'll have intelligent buildings, we'll be using these tools to produce much more smarter buildings and smarter ways of operating, and to maintain our buildings in a smart way. So I think that we have to really raise the profile of the notion of information over our traditional architectural logic of form. No, we think in terms of form. We architecturalize things. We translate things into form, but which is amazing. No, don't get me wrong. That's incredible. It's an amazing facility. But I think as architects, we have to be aware of these informational systems and how they're going to transform the way in which we propose those forms.
Thank you. Thank you so much, sir.
Yes, I think this brings us to the end of this amazing session. I'm sure all of us, including Neil, is leaving with lots of more questions. So, Atre, would you like to just give final comments?
Well, thank you, Neil. I think it was wonderful. I think, lots of interesting questions, a lot of interesting thoughts and ideas. Brings back, readings of Asimov to Toffler to, I don't know, and looking forward to, I think, a lot of your work in the upcoming AD publication. I think I'm really, it was thoroughly, a pleasure to kind of have you here. And hope that, I think, we can begin some more associations with you. Of course, at a kind of a personal level, but also in terms of, if Digital Futures also kind of works with schools at some point, I think it'd be great to kind of start here, I guess. We would be very happy to have some associations even along those lines. So do let us know where, and I think Baldwin has a kind of a direct hotline, I guess, to that as well. So I think we'll
just one comment that was made by Philippe Morel, who's on our DDS. He said, the role of Digital Futures is to do to architectural education what Uber did to taxis. In other words, to improve its act. And actually, it seems like you've got a very enlightened school there in Mumbai. But there are places in the world where that's not the case at all, right? And I think that so we're just providing this content, shall we say, that is there as a resource, a bit like TED Talks in some sense, and that's an important thing in itself. The next step, of course, would be to move into whereby we use some of these things educationally, and that's already happening to some extent, in the sense we have this doctoral consortium, a platform where we're trying to share all these ideas to everyone. It's our view is that we need to democratize education. I've having taught in all these different schools all over the world, you begin to realize there is talent everywhere, and it doesn't depend on whether you can afford to go to the AA or something like that, you know. And what we're trying to do is share that knowledge and share this passion for architecture with a view to try and improve it, you know. A bit like IAC trying to improve, you know, it's there to kind of as a kind of a stimulant to try and improve the rest of the world. So yeah, it would be great to try and think about how we could use this and bridge this in some way. There is a new domain that is opened up on online education that allows these kind of events to happen, which could have happened, never happened before. And you know, I think it's almost like the Wild West. There's this whole new territory we can explore, and we don't even know where it's going yet. We don't even know what Digital Futures is doing, but all we're finding out is that people are very receptive to that idea, and we want to push it further. So that's why I have to thank Bavleen for incredible work that she's done in terms of Digital Futures and taking charge of our technical tutorials in the future. But there is a world out there, and it's an exciting one. I guess that's the point I want to kind of put across to you, is that this is amazing. I mean, this stuff is from a theoretical perspective, it absolutely, I've never felt so energized, you know, by a new idea as the kind of constellation of new ideas that's happening. The world of neuroscience, the world of AI, opening up issues, theoretical issues, what is about what is human intelligence, but it's also doing something as well, opening up possibilities for the architectural imagination and how we can deploy that very amazing and original thing. And just one final kind of comment, you know, let's not underestimate, you know, all this thing about AI being better and so on. There are some incredible things that humans can do that I think we're beginning to realize. You know, I always think that, you know, so let's say AI can produce, you know, some whole range of options. What we're able to do is to discern very quickly what is good and what is bad. You know, I don't want to upset the students here, but when I look at the portfolio, I don't spend 20 minutes looking at the portfolio. I can see in about 10 seconds how good someone is. And I go to a bar somewhere, have a cocktail. I can tell with the first sip whether it's good or bad. I go to a restaurant, you can tell immediately. And I think there's something about that. Once you combine that kind of human capacity with this incredible tool, you get something that is superhuman and something very special. And you know, I think we have a responsibility to open up, to explore what avenues of possibilities there are in this new domain. So I'm waiting to see India take a real leading role, because you guys are so good at computation. I'm sure. My prediction is we're going to see some more Chargé-Bouchons in the world are going to come through. That's for sure.
Yes, let's hope. I think it's a better word for all of us, I guess. Then.
Yes.
Thank you again, Neil.
Yes. Thank you, everyone, for staying up.
All the students for staying up so late. I think, well, I mean, some of them might just land up having another day after this, you know, in whichever other world that they occupy. So, well, to tomorrow.
Can I just leave you with one thought from my students in Nottingham years ago? They had these T-shirts, and their motto on the T-shirt was, "You can sleep when you're dead." I mean, architects stay up late; they do all night. But thank you for staying up, all you guys. What time is it there now?
It's close to 11:30.
Yeah. Okay. So to many more conversations. Thank you so much, Neil. Thank you so much, everyone. We'll see you.
Thank you.
Thank you so much, sir.